All right, let's go ahead and get started. I'm having to go back the door to try to get this thing videotaped, so I'll see what I can do. In case some of you guys don't know, my name is Dr. John R. Taylor. I'm the other instructor for calculus. You may know my wife, Desiree Taylor. This is the Calculus 2 review, final exam review, where I'm going to be doing the fall 2019 exam. Now, before I do that, there's a couple of housekeeping things I would like to do for my class. First thing is this. I have 2 sections of Calculus 2 this semester, and they just had their test number 4 just the last Tuesday. And here are the multiple choice part of the questions. So version A, version B in one folder, version A, version B in the other folder. Try to keep the folders together as you pass them down. If you're not in either one of these classes, just keep passing them to your friends, and I'll pick them up at the end. All right, in section 7 and section 8. So keep them together. Big section, small section. All right, question? Yes, ma'am.
Where's the Calc 1 part?
If you need the Calc 1 review session, that is in Fretwell 100. This is the Calc 2 review session. So if you're in Calc 1, you're going to be very unhappy with the things that we're about to cover. So it's in Fretwell 100. The Calc 2 is in Fretwell 121, but they're at the same time. So, all right. The other thing I want to discuss with you guys is my class. Let's see here. Raise your hand if you're in one of my 2 classes. All right, good. I'm picking on you people. So you other people listen along because yours isn't any better. All right, let's talk about your test number 4 grades. Pathetic. Pathetic. Class average was a 60. And let me tell you, if you're in Professor Taylor's class, Desiree class, your average wasn't even better. All right, so really sad on this particular test number 4 material. Because let me tell you something, brother. This is important material. So I do also plan on, I have a free response part of my little test over here and some of the multiple choice part. But I am also, in terms of my review, I'm going to go over the free response part of the test. Now let me explain why. I am signaling to you guys what you can anticipate on the final exam. So here is the free response part for version A. And I'm going to go over this thing with you because it should take about 5 minutes to do it. But some of you people took way too long and stuff like that. Some people just left it blank. How idiotic is that? You never leave anything blank. Listen to me. This is the final exam. I'm trying to prepare for you guys. There is 3 parts to the final exam. There's a multiple choice part, no calculator. Multiple choice part with the calculator, and then a free response part with the calculator. This is a classic example of what we're going to do to you guys in terms of the free response. You're going to see a question very similar to these type of problems, where you're using these power series to estimate something or other. You are mimicking what the calculator is doing. Understanding the programming. For my computer science majors, you should be excited. For my electrical and mechanical engineering majors, you should be excited. Math majors should be excited. Civil engineers, deal with it. So we're working on understanding the programming of these particular problems and stuff. Okay? So I will be taking a look at this at the end. So I'll put that at the back part of my little exam right here. All right, so today I'm covering the fall 2019 exam. The fall 2019 exam is the exam that was the last one before we hit COVID. So this is the format. We did change the front page, so do not be alarmed by this. So this is the first part of the exam. Part number 1 is the no calculator section. Okay? So with that being said, this is what the front cover is going to look like on your exam. So, again, we're going to be using GradeScope to kind of help us out with the management of this system. You want to put your last name, your first name, your ID number, and then your professor. For my guys, it's Dr. Taylor, John Taylor, if you want to know particular. If you're in Desiree's class, it's Professor Desiree Taylor, and your section number. Okay? So make sure you know which section numbers. And for my guys, it's section 7 and section 8. Our exam is going to be over in Epic. We've quizzed you guys about that. Also, to remind you guys, there is a quiz that I put on Canvas. I sent you guys an email about this, about a final exam info quiz. I know you guys in Professor Taylor's class are also have the exact same type of quiz about where your exam is going to be at. It's free points. So enjoy this, but make sure you do it because you're going to miss out on some free points if you don't. For my class, it is due by 11:59 tonight. So if you haven't done your final exam info quiz, let you know where the final exam is, and the things you got to bring: pencils, calculator, and your student ID stuff. Bring that with you to the exam. And of course, the exam starts at 5:30. That'll be tomorrow. You got to be there a little bit after 5 o'clock. Go ahead and get your seat and get yourself set up, okay? Because we're going to pass out the part of the test, and you're going to fill out that front page and stuff. And right at 5:30, you open that test booklet and you get started. All right? So let's get started on this particular one right here. So this is part 1, no calculator. For the first hour of the exam, no one's allowed to use a calculator. On this particular exam, I believe there was 15 questions in terms of the multiple choice part. They're going to vary. I think that on our exam it's going to be about 15 questions as well. And then there's a part 2 with the calculator, but even then, most folks finish up with part 1 in about 30 to 45 minutes. But you have exactly up to 1 hour. After 1 hour, you have to turn this in, and so you can start on test part 2 and part 3 with the calculator. We give the official word. You're allowed to use your calculator. Well, geez, Dr. Taylor, I already turned in part 1, and I was just going ahead part 2 and 3. It says I can use a calculator. I could use my calculator. No, not until we give you the official word, because we got so many students in class, we don't know who's got part 1 and who's got part 2 and 3 working on this stuff. So until we collect all the part 1s, nobody's allowed to use their calculator. But trust me, on part 2 and 3, you can do most of that test without a calculator. Okay, it's about knowing all this stuff. Now, got a question for you guys as I'm starting this. Question for you. This is part 1 of the final exam. Haven't even opened the booklet yet. What kind of questions are they going to pose to us in a Calc 2 final exam with no calculator? What do you think the question is going to be? Integrate everybody. You got it. Integrate, 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 integrate. So remember that. And there'll be some stuff you have to calculate, but it'll be basic numbers you plug in. Add, subtract, multiply, and divide. But again, no calculator on this thing. So here we go. So here comes my first question right here. And it is this. Quote, consider the graph of the function of f between 0 and 1. All right? What's the integral of this thing? Well, when you integrate, you get the area under the curve. So same first problem. Area under the curve between 0 and 1 is this particular part right here. Okay? So it's a triangle. So the area of a triangle is 1/2 base times height. The base is 1. The height is 3. So it'll be 1/2 of base is 1. The height is 3. So clean this up. 1/2 there, John. And so you end up 1 times 3 is 3 times 1/2 is 3/2, and you got your first answer. Bubble it in. So usually the first problem is going to be very straightforward, some basic concept that you learned from the first one. Now let's take a look at the next guy. I want to integrate. And look, it's got bounds. Don't worry, you're going to be chunking in these numbers here. What's the integral between -1 and 2 of 4x cubed dx? Well, first thing you got to do is integrate. 4 is a constant, leave it alone. Integral x cubed, add 1 over add 1, is x to the 4th over 4. And then you want to evaluate it from -1 to 2. So this cancels. So this pretty much gives you x to the 4th, evaluated from -1 to 2. And now I want to plug in top minus plug in bottom. So this will be 2 to the 4th minus -1 to the 4th. Basic math. What's 2 to the 4th? That is 2 times 2 times 2 times 2. What is that? 16 minus -1 to the 4th. -1 times -1 times -1 times -1 is 1. So what do I get for the answer? 15. And so I go and circle that answer. It's A. And you'll bubble it in on your grade scope OpScan form. Is that bad? Let's look at the next one. The integral of the cosine of 1 plus 2x dx. All right? This is not a basic rule I have memorized, so what technique of integration will I use?
U substitution.
U substitution. What are you going to let U equal to? Inside parentheses, 1 plus 2x. Then you've got to do du. Derivative of 1 is 0. Derivative of 2x is going to be 2 dx. Move your constant to the other side, so I get 1/2 of du equals a dx. Does that make sense? When I substitute, this problem is going to turn into the integral. This was a cosine function. This part was u, and then the dx turns into a 1/2 du. Now, the constant gets to be pulled out front, so this is 1/2 the integral of the cosine of u du, and now, basically, you just got to integrate. Pure memorization. What is the integral of cosine of u? And don't screw this up, because you know if you screw up the sign, that answer is also going to be in that multiple choice part, because we're banking on, that's what most people make a mistake on. What's the integral of cosine of u?
Positive sine.
Positive, so it'll be 1/2 the sine of u up plus c, and then I back substitute. This will be 1/2 the sine of 1 plus 2x plus c, and then I go find my answer. My answer is E. Does that make sense? Questions? Okay? So, let's keep going. Look at the next one. Okay? Pages this way so it's easier to keep up with them. All right, take a look at number 4. Number 4 is the integral from 0 to 1 of x times x squared plus 1 quantity cubed. Well, again, what technique of integration would I use on trying to integrate something like this? U substitution. Again, I'm going to let u equal to, in this case, inside the parentheses, being raised to the power. That is at x squared plus 1. Then du, my derivative is going to be, derivative of x squared is 2x dx. Don't forget to put your d stuff on there. I move my constant to the other side. 1/2 du is equal to that x dx, and you'll notice that x dx is in the problem. That's how you know you got u substitution correct. So when I substitute, this will turn into the integral. This part was u. You're cubing it. And the x dx is going to turn into a 1/2 du. I'll go ahead and stick the constant out front and the du in the back. I could switch bounds if I want to right now. That's up to you. And then I don't have to back substitute. But since I'm practicing for the final exam, I'm going to do the back substitution in case there was no bounds. So this is equal to 1/2 the integral of u cubed. Add 1 over add 1 is u to the 4th over 4. Cleaning that up, that becomes 1/8 of u to the 4th. Back substitute, this is 1/8 times u. U was x squared plus 1 to the 4th. And we're evaluating it from 0 to 1. Again, you do expect numbers on this stuff, but they're going to be easy numbers. Fundamental theorem of calculus. Plug in top minus plug in bottom. This would be 1/8 times 1 squared plus 1 to the 4th minus 1/8 times 0 squared plus 1 to the 4th. 1 squared is 1, plus 1 is 2, so this is 1/8 times 2 to the 4th minus 1/8 times 0 squared is 0 plus 1 is 1, and that'll be 1 to the 4th. Well, what is 2 to the 4th? We just saw that a few seconds ago. That's 2 times 2 times 2 times 2, which is 16. 16 divided by 2 is, 16 divided by 8 is 2. Minus 1 to the 4th is 1. Times an 8 is an 8. So I end up getting 2 minus an 8. Well, by the way, 2 is 16/8 minus 1/8. What is my answer? 15/8, which happens to be right there. So far, so good? Let's keep going. Problem number 5. What is the integral from a to b? So in this problem, they put numbers, they put variables, or just constants, a and b, of x squared times e to the x cubed dx. Again, this is an integral that I do not have memorized. So what is my number 1 technique of integration? I'm going to try u substitution. And if u substitution does work, then I go to integration by parts. But this one, I'm going to try u substitution, and I'm going to let u equal to what? The exponent, x cubed. So du is equal to, derivative of x cubed is 3x squared dx. Move my constant aside. 1/3 du equals x squared dx. And I pause and hesitate. Now look, is there an x squared dx in this problem? Yes, there is. So this will convert into the integral. This was an e problem. That was e to the u. But the x squared dx gets replaced with a 1/3 du. Just to save time, I put my constant out front, 1/3 du in the back, and it should turn into a formula that I have memorized. What is the integral of e to the u? E to the u, so this will be 1/3 e to the u, but no plus c's on this thing, so we've got bounds. So then I'm going to back substitute. And when I back substitute, this would be 1/3 e to the u was x cubed, and then we put our bounds on there from a to b. So according to our fundamental theorem of calculus stuff, plug in top minus plug in bottom here, this would be 1/3 e to the b cubed minus 1/3 e to the a cubed. Now from this point, I'm starting to look at my particular answers, and I'm starting to figure out, okay, they cleaned it up, but all they did was pretty much pull out my constant, which is that common 1/3. That'll be 1/3 times e to the b cubed minus e to the a cubed. There is my answer, which means the answer is C. Does that make sense?
Quick question. How much work are you expecting to see on some of these problems?
On the multiple choice questions, excellent question. You can be as messy or not so messy as you want, because we're just grading your final result. It's a multiple choice question. On the free response, you go out of your way to show the detail of your work, because we grade your work, not just the answer on the free response stuff. So you really want to go out of the way to be neat and show your work on the free response question. Okay? So, look at the next one. And again, problem recognition is key to this stuff. So if I look at the next problem here, I got the integral of x, e to the x, integral of x times e to the negative x dx. Well here, u substitution doesn't work, because I would let u equal to, obviously, the negative x, then du equals negative 1 dx, and there's an extra x out here that never got substituted for. All right, so my u substitution, and then when I convert it over, it's still going to kind of be the same thing, integral of u, e to the u type thing here. So it really did change the form. That's kind of the purpose of u substitution. And you should recognize this. This idea of x, e to the x type thing here is typically an integration by parts. This is an integration by part problem. So this would be, knowing your formula, integral of u dv equals uv minus integral of v du. And again, every problem that I'm showing you guys is I'm showing you detailed work, because just in case this problem shows up on the free response, this is the work we want to see. So here, what are you going to let u equal to, and what are you going to let dv be? You want to let u equal to the part you want to get rid of. Remember your Lytle principle. The Lytle principle is logarithms, inverse trig, algebra, and the last two things are going to be trigonometry and exponents, right? So in terms of my hierarchy, I don't see any logarithms, I don't see any inverse trig, but I see a little algebra, x out front. I'm going to let u equal x, the part I want to get rid of, and dv would be the other part, e to the negative x, dx. So you're going to take du, the derivative of x is 1 dx, and then I integrate dv. Now this is integral e to the negative x dx. Again, reminding you of formulas. As you're studying these old final exams, you should write down formulas that you are using. This is the classic e to the kx. The integral of e to the kx is 1 over k e to the kx. Things you have to have memorized. K is negative 1 here. So this will be 1 over negative 1 e to the negative x. And using k as negative 1, just write it to this form. Okay? And of course, that will clean up to be negative e to the negative x. And I plug it into my formula. So my integral is going to be u is x, times v minus integral of v du. And I wanted you to see this integration by parts, literally plugging in the parts. There's the u. What was v? Negative e to the negative x minus integral of v, negative e to the negative x, and then the du is just 1 dx. The next thing you want to do is clean up this by parts. This is negative x e to the negative x. A minus makes it plus the integral of e to the negative x dx. This, again, is a formula that we just did, the integrating of this guy. It's that 1 over k e to the kx stuff. The integral e to the kx, k is negative 1 here. So this becomes negative x e to the negative x plus 1 over negative 1. K is negative 1 e to the negative 1x plus c. And then, of course, the last thing I want to just clean that up. This is negative x e to the negative x plus 1 over negative 1 is minus. So plus a negative is minus e to the negative x plus c. And there's my answer. Now, finding them on the lineup, I believe that is answer D. Does that make sense? Questions? All right. Number 7. If f of x is equal to the integral from 1 to x cubed of the sine of x squared dx, then find f prime of x. This is what we call that fundamental theorem of calculus part 1 from your textbook and your guided notes. The derivative of an integral, you don't go anywhere. So this is the same idea as the f prime of x is the derivative of the integral from 1 to x cubed of the sine of t squared dt. Now the derivative and the integral cancel, so you're just going to be left with the function, the sine of something squared, and then replace the something with the function x cubed. Okay? The derivative and the integral cancel, and you just plug in top. Minus plug in bottom. But anything other than x, you got to use the chain rule version of this stuff. So, well, you plug in x cubed, but then chain rule times the derivative of what you plugged in. What's the derivative of x cubed? 3x squared. Now, it's minus plug in bottom, but the bottom is a constant. And then you got to do times the derivative of the inside, but what's the derivative of a constant? 0. So we don't care about constants because they'll all end up being 0 when you take its derivative from the chain rule version of this thing. So there's my answer. I want to clean that up. So f prime of x is going to be equal to 3x squared times the sine of power to a power. What do you do with the powers? Multiply. X cubed squared is x to the 6th. And no plus c's on this mess. This is my answer, which makes the answer C. Fundamental theorem of calculus. Now, if it was just an x, you basically derivative integral cancel, you get sine of x squared. But any other thing other than x, you got to use the chain rule version. So you plug in derivative integral cancel, you just plug in whatever into the function, but then times the derivative of the inside. Chain rule version of this guy. Okay? Again, remember, no calculators on this thing here. So, here we go. Find the area under the curve, or under the graph. I'll slide down so you guys can see that other last problem there. Find the area under the graph of y equals x squared and above the x-axis. Again, reviewing your skills. What's the whole purpose of integration of a function? It gives you the area under the curve. So, again, if you want to just graph this guy, you don't really need a calculator for this. Y equals x squared is pretty basic. That's your parabola going through the origin there. All right, and our bounds are between -1 and 1. And there's a couple of ways I could do this problem, but this is typically what we want to calculate, is that area. And to calculate that area, all I got to do is integrate my function, which is x squared dx, over my bounds between -1 and 1. Well, what is the integral of x squared? Well, add 1 over add 1, that's x cubed over 3, evaluated from -1 to 1. The fundamental theorem of calculus, part 2, according to our textbook author, Dr. Stewart, plug in top minus plug in bottom. This would be 1 cubed over 3 minus -1 cubed over 3. 1 cubed is 1/3 minus -1 cubed is -1/3. But minus a negative makes it plus, so this is 1/3 plus 1/3. So the answer is 2/3, which is the answer C. Another way I could have done this problem is just integrate from 0 to 1 and double it using symmetry. Because if you're worried about plugging in negative numbers without a calculator, well, fine, use some symmetry on this thing. Question? Yeah.
Would you also be able to calculate the area by doing like the area of a triangle for both or not really?
No. This is, you want the exact area and stuff like that. The only time we're going to do that type of thing is with those Riemann sums, and we will throw that in your face like, use Simpson's rule, trapezoidal rule, or midpoint rule. That's the kind of stuff we're going to make you do the kind of estimate the area type thing. Okay? All right, let's take a look at this guy. And notice another thing. I could do this test a lot quicker if I didn't have to write down every step. But I'm writing down every step for you guys because every one of these problems could be a little section within the free response part. This is the work we expected to see on this one. And of course, it's the right answer. And you got 3 hours for this exam. Sit back and enjoy. Do not rush through this thing. You might as well make sure, because most people, especially in my class, their biggest problem is bonehead careless errors. You know, x squared cubed. Clearly that's x to the fifth. No, when you multiply power to a power, you multiply. You don't add. And they do something just lame that they should have known better. But you know, you guys are engineers. You screw up one bonehead careless error. Bridge doesn't make it on the other side of the river, and people die. And it's all your fault. You got to watch your careless errors. So be careful on this stuff. Take a look at this guy here. Improper integral. This is the integral from 2 to infinity of dx over the square root of x. This is an improper integral. Now, again, you asked me the question about how much work do we have to show. I don't have to hardly show any work at all if I want to kind of skip over some steps, because this is free response. But, I mean, this is multiple choice, not free response. But if this was free response, this is what I would expect to see. This is equal to improper integral, clearly that infinity on the bound there. Pick my favorite letter, a approaches infinity of the integral from 2 to a. I would clean up my function. I don't do square roots. That's a half a power. I don't do them on the bottom. I bring them to the top. That's x to the negative 1/2 power dx. Then this is equal to, and this is showing your work. So you keep writing this limit statement. Now integrate x to the negative 1/2. Add 1 over add 1. That's x to the positive 1/2 over 1/2. And you put your bounds on this thing from 2 to a. I would clean that up one more step before I start plugging in my bounds. A half a power is a square root, but when you divide by a half, you invert and multiply. This would be 2 times the square root of x, evaluated from 2 to a. Fundamental theorem of calculus, you plug in top minus plug in bottom. This is the limit as a approaches infinity of 2 times the square root of a minus 2 times the square root of 2. Now, take the limit as a approaches infinity. When I do that, I plug in infinity. I don't write limit anymore. That's the square root of a is going towards infinity minus 2 square roots of 2. Now, we should know that the square root of infinity is infinity. So this is infinity times 2 is infinity minus this 2 square roots of 2 number, which means it's infinity, which means it is what we call divergent. The answer is it diverges. The answer is A. However, again, I'm trying to prepare you guys for the final exam. On occasion, we would put 2 different diverging kind of answers on a multiple choice. Does it diverge to infinity or diverges to negative infinity? On this example, we just said diverges, but we could put diverges infinity or diverges negative infinity. This is a divergent to infinity answer. Does that make sense? Just a little subtle difference that you may see comparing questions and stuff. All right. Again, this one typically surprises people and stuff. Consider the following table of function, and we want to use the midpoint. Well, geez, Dr. Taylor, how can I do that when I don't have a calculator? Well, let me show you. It'll be basic numbers. I mean, add, subtract, multiply, and divide on, worst thing, a fraction. That's about all you're going to do without the calculator stuff. So, here we go. All right, consider the following function, a table of values of the function f. So we got x, 0, 0.25, 1/2, 0.75, and 1, and these are function values, 2, 3, negative 1, 4, 6. Use the midpoint rule with 2 subintervals, that means n equals 2, of equal length to approximate the integral from 0 to 1 of f of x dx. So we're approximating it with the midpoint for 2 partitions. So let's remind ourselves of the midpoint formula. It's the sum of f of x bar, with the midpoint here, times your delta x. So the first thing I'm going to do is calculate my delta x. What's my delta x formula? B minus a over n, which is b, which is here, a is 0, b is 1, so it'll be 1 minus 0 over n is 2. That makes it 1/2, okay? So my partition level is going to be 1/2. Delta x is equal to 1/2. So let me show you this on the chart. Delta x is 1/2. So that's from 0 to 1/2 and from 1/2 to 1. Does that make sense? And it creates these guys as your midpoints. My midpoints end up becoming the 0.25 and the 0.75. So this would be equal to basically the sum, which is f of your first midpoint between 0 and 1/2 is 0.25, plus your second midpoint f of 0.75 times that delta x. Now, again, I'm trying to show you the work because I know we have a calculator program for this bad boy, but here's the deal. I'm not using my calculator program on this one. I got no calculator on this one. So we got to use the chart. So f of 0.25 is 3. So this will be 3 plus f of 0.75 is 4 times, what was your delta x? That was equal to 1/2. Does that make sense? So let's not hurt ourselves. 3 plus 4 is 7 times 1/2 is 7/2. Does that make sense? So notice the numbers. Don't be alarmed by it. Worst case is a fraction here. 7 times 1/2, 7/2. The answer is D. Does that make sense? Did I lose you guys anywhere with this? So again, midpoint, you may see a Simpson's rule with a chart or something like that. Just make sure you know your basic formulas for these things. Midpoint, Simpson's rule, and trapezoidal rule. Okay? The next one is this. Which of the following is correct? Well, again, we're showing you different ways we could ask questions. But if you look at this thing here, this guy really is this problem here. It's all the same question. What is the integral of x to the 4th e to the x dx? Now, if I actually integrate this guy out, this is going to be an integration by parts like 4 times to finally get rid of that x to the 4th here. But you should recognize this is not u substitution. You've got the e to the x times some kind of a function in front. That's integration by parts. That's the integral of u dv equals uv minus the integral of v du. Okay? So on this one, what am I going to let u equal to and what am I going to let dv be? Well, you want to let u equal to the part you want to get rid of, and your Lytle principle, the thing you're going to get rid of is the x to the 4th, the algebra. Okay? There's no natural logs, there's no logarithms in this thing, there's no inverse trig, there's algebra. The last thing in the world I ever want to let u equal to an integration by parts is e, the exponential stuff. So that's got to be the dv. The dv is the e to the x, the dx part. Then I take du, the derivative of x to the 4th is 4x cubed dx. Then I integrate dv, this is about as easy as I can make it. What's the integral of e to the x dx? E to the x. And now I'm going to plug it into my formula, and then my formula is that u times v minus the integral of v du. U is x to the 4th. V is e to the x minus the integral of v, which is e to the x, du is 4x cubed dx. And literally, I'm just plugging it into the parts. Of course, I'm going to clean this up. This is x to the 4th, e to the x minus the integral, I like to put my function out front, 4x cubed e to the x dx. And look at your answers. They only wanted you to do this integration by parts one time, which makes the answer what? Boy, not 1/5 thing, 4x cubed. So the answer is C. X to the 4th, e to the x minus the integral of 4x cubed times e to the x dx. Does that make sense? Questions? Pure memorization. We taught you guys in chapter 8.7, looking at your last test scores, you obviously didn't heed our warning on this. You were supposed to memorize 5 Maclaurin series polynomials. The 1/1 minus x, the sine of x, the cosine of x, the e to the x, and the arctangent of x. You're supposed to memorize those formulas. So when you see them, you can recognize them and get free points. Here it is right here. Which Maclaurin series is this guy? X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Well, I'll remind you, these seem to be the odd powers. With the factorials on it, makes it one function altogether. Which one is it? Sine of x. and that is pure memorization. The even powers with the factorials is the cosine. If I dropped the factorials, then the answer would have been the arctangent. That's sad. I would have put that as part of the question, but they didn't even give you that option, the arctangent. But okay, remember that on the next exam. Is that if the factorials weren't there, it's the arctangent. The e to the x, the classic one is 1 plus x over 1 factorial plus x squared over 2 factorial plus x3 over x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot. I mean, the power series or the Maclaurin series for 1 over 1 plus x is 1 plus x squared plus x cubed plus dot dot dot. Pure memorization on these guys. And there was a pattern to them. That's what we kept trying to teach you guys in class. I can't actually explain it better than this. Recognize it. This is one of those formulas you're supposed to know. It's C. It's the sine of x one. Does that make sense? And there's no work in this problem whatsoever. It's problem recognition. Did you memorize the Maclaurin series for the sine of x? Look at the next one, problem number 13. It says this. The region in the first quadrant bounded by the graphs of y equals x cubed, y equals 0, x equals 1 is rotated about the x-axis. Find the volume of the particular region. Oh my goodness, we want to do one of these problems, and when we did this in chapter 7, we always had calculators. Well, it's basic. Let's take a look at it. Now, first thing you want to do is draw the picture. You should know what x cubed looks like, big old squiggly right through the origin. And the thing we're talking about is in the first quadrant, so I don't really care about this part here, but it comes in here and looks like that. There's my y equals x cubed. Let's see here. Y equals 0, we know that better as the x-axis. X equals 1 is a vertical line. Here's x equals 1, and I declare it to be this guy right here. And between all three of these equations, clearly we're talking about this region here that's been captured by all three of these lines. We want to rotate this thing about the x-axis. So the axis of rotation is the x-axis. So let's go through this to make sure you know it. My function of my region is in terms of x. The outside bound is x cubed. It's in terms of x. We are rotating about the x-axis, or maybe something parallel to the x-axis. What method do I use on volume rotation? Dishwasher. Outstanding. Disk washer. Things you're supposed to know. Disk washer, which is the formula. Volume is equal to pi times integral from a to b of your big functional radius squared minus little functional radius squared dx. Disk washer method. Now, if the function was in terms of x, and I wanted to rotate around the y-axis or something parallel to the y-axis, then I would use the shell method. Okay, 2 pi times integral of point radius times f of x top minus g of x bottom. Pure memorization on the formulas. You've got to know them. So, what is my big point radius here? My big point radius, big functional radius here, r, what's my big functional radius, r, is from the axis of rotation to the outside edge, there's big R, which would be x cubed. The little radius is from the axis of rotation to the inside edge, but the inside edge is the axis, so that would end up just being 0. So if I plug this thing in here, just be careful, volume is equal to pi times integral from a to b of your big functional radius, which is x cubed squared minus 0 squared dx. And what would my bounds be? Where's the bounds of the region? Between what two numbers? 0 and 1. So now we got to clean this guy up, and like I said, I don't have a calculator for this thing, but don't need one. It's pretty basic. It's pi times integral from 0 to 1, x cubed squared. Power to a power, what do we do with the powers? Multiply x to the 6th dx. So now, integrate, hold that pi, integral x to the 6th is x to the 7th over 7, evaluated from 0 to 1. Fundamental theorem of calculus, plug in top. This would be pi times 1 to the 7th over 7. Minus pi times 0 to the 7th over 7. I did that just for your benefit here. That's 0. So what's my answer? 1 to the 7th is 1 over 7, is 1/7 times pi, is pi over 7. Officially units cubed here because it is volume. But it's pi over 7. Looks like my answer is D. Does that make sense? Did not need a calculator for this one. but you had to set it up. So remember the disc washer shell method. The other thing, as I go through this exam, you should be having a little side piece of paper, a little side sheet of every time we do something of a formula, you need to remind yourself of it. This was the disc washer formula, and might as well probably on the next test to be the shell method. So make sure you kind of go over those. You're basically logging in formulas that you may have not seen in the last month or whatever. Okay, so it's reminding you of these formulas that you have done before. All right, take a look at this guy right here. Number 14. It's the integral of x cubed plus x plus 2 divided by x squared plus 1 dx. Well, I'm going to integrate this guy, but I'm integrating fractions. That's section 6.3. And first thing I notice about this particular fraction is that the degree of the numerator is bigger than the degree of the denominator. If the degree of the numerator is the same size or bigger than the denominator, when the top's bigger than the bottom, you don't have a choice. You got to do what to be able to clean this guy up? Long division. All right, this is why we study. Okay, long division. Degree of the top is bigger than degree of the bottom. It's long division. And then if I look at the bottom, I don't know if it maybe you got a bigger quadratic. If it factors, then you're looking at that partial fraction stuff. But not on this one. It's pretty much, look at it, x squared plus 1. But anytime there's a term missing, I always put a 0 in for it. So it'll be x squared plus 0x plus 1. That's my divisor. My dividend is x cubed plus 0x squared plus x plus 2. If there's a term missing on these polynomials, they got to be in decreasing order, put a 0 in for it. It makes things line up so you don't make a bonehead careless error. Now, let's play the game. What times x squared is x cubed? X. I distribute. X times x squared is x cubed. X times 0x is a 0x squared. X times 1 is a 1x. And then I'm going to subtract, which changes my signs. This will cancel. And so does this one and this one. That's awesome. So what am I left with? You bring down your next victim, 2. But x squared doesn't go into 2, so this guy's called the remainder. So how do I write my answer? This problem now turns into the integral of my quotient, which is x, plus the remainder, which is 2, over the divisor, x squared plus 1 dx. Quotient plus remainder over divisor after you do your long division. Now I just got to integrate both terms. Now, this becomes integral of x dx plus 2 is a constant. That'll be 2 times integral of 1 over x squared plus 1 dx. Now, I wrote it like this for your benefit because I wanted you to see something of it. Here it is. What is integral of x? Add 1 over add 1. What does that become? X squared over 2. Plus 2 is a constant. It holds over. What is the integral of 1 over x squared plus 1? 1 over what now? No, there's no 1 over. What is the integral of 1 over x squared plus 1? Outstanding. This is a formula you would need to memorize. There were those 3 inverse trig forms that you made to memorize. So this is the arc tangent of x plus c. Okay? So what is my answer going to end up being? Well, even if you got the first one right, you should have been able to mathematically come up with the right answer. It's sad, but hopefully we'll do a better job in trying to fool you guys in terms of wrong answers on the next exam. It's got to be this guy. But since you brought it up, let me remind you of the 3 inverse trig formulas you need to know. Those are the integral of 1 over x squared plus 1 dx. That's arctangent of x plus c. The integral of 1 over the square root of 1 minus x squared dx is the arc sine of x plus c. And the last one is the integral of 1 over x times the square root of x squared minus 1 dx. That is the arc secant of x plus c. Those are the 3 inverse trig formulas that you need to have memorized. Again, as you do exams, and don't let this be the only exam you guys cover. Make sure you cover, more of them. Okay, so you can come up and collect formulas that you need to go back and memorize. All right, last one is another one from your classic problem of power series. They want to find the interval of convergence. for this power series. The sum as n goes from 0 to infinity of n times x minus 2 to the n. All right? Anytime I'm looking for interval of convergence on something like this, I'm going to use the famous ratio test. I'm going to take the limit as n approaches infinity of the absolute value of an plus 1 over an, which is equal to the limit as n approaches infinity of the absolute value of n plus 1 times x minus 2 to the n plus 1 divided by an, which is n times x minus 2 to the n. Clean it up. X minus 2 to the n plus 1 is the same thing as x minus 2 times x minus 2 to the n, and the x minus 2 to the n's will cancel. You're left with the limit as n approaches infinity of the absolute value of n plus 1 times x minus 2 divided by n. Now focus on the n's. What is the limit as n approaches infinity of n plus 1 divided by n? You can use L'Hopital's rule if you want to, but since the degree of the on the ends, because the degree of the top is equal to the degree of the bottom, what is this thing going to go to? 1. So that goes away, and you're left with the absolute value of x minus 2. Now this is the ratio test. So when does the ratio test converge? We're going to force it to converge. The L, which is now a function of x, has to be what? Less than 1 to be able to converge. Ratio test to converge. I'm going to solve this guy. This is negative 1 is less than x minus 2, which is less than 1. Solving for x in the middle, add 2 on all sides, and that pretty much gives me 1 is less than x, which is less than 3. So it's between 1 and 3. So I now got it down to a 50-50 shot. But now you got to test the endpoints. My endpoints are x equals 1, and my other endpoint is x equals 3. I'm plugging back into the original series for x. This will be the sum as n goes from 0 to infinity of n times 1 minus 2 to the n. This cleans up to become the sum as n goes from 0 to infinity of negative 1 to the n times n. 1 minus 2 is negative 1 to the n. I just put him out front. What kind of series is this guy? And don't hurt yourselves. Negative 1 to the n. What is it called? Alternating series. So I'm going to use the alternating series test. However, in this problem, the Bn is actually equal to n. So for two things I got to show. The terms go down, but here's my problem. N equals 1, equals 2, n equals 3. Plug in n equals 1, I get 1. Plug in equals 2, I get 2. Plug in equals 3, I get 3. They're not going down, they're going up. That's bad. But number 2 really kills it for me. What's the limit as n approaches infinity of the Bn? What's the limit as n approaches infinity of n? Infinity, which is not 0, which means this thing, according to the alternating series test, diverges. So we do not want this point in my interval of convergence. Does that make sense? So that pretty much narrows down the answer. It's going to be D. But I'm just going to show you on the other side. When I plug in x equals 3 into this series, this becomes the sum as n goes from 0 to infinity of n times 3 minus 2 to the n. 3 minus 2 is 1, and 1 to the n, so I'll write it for you. The sum as n goes from 0 to infinity of n times 1 to the n. But 1 to the n is going to be just 1. This is the sum as n goes from 0 to infinity of n. Now, your sequence is n. Notice that if I take the limit as n approaches infinity of n, I get infinity. What test is this called? There's 7 tests on these series you're supposed to know. This is called the divergence test. It is not 0. So by the divergence test, guess what this thing does? Convergence. No, that's absolutely idiotic. People tell me that crap all the time. It's called a divergence test. What does it do? It diverges. So we don't want the 3, x equals 3 either. So this becomes my interval, and clearly the answer is D. Does that make sense? Did I lose you guys anywhere? Now, remember, I took this exam. I started a little bit late because I had some housekeeping chores to do for you guys. It honestly took me about 35 minutes to do this thing. No, I'm talking about this part 1 right here. We're with you guys. And I had to explain it to you guys. And this is average amount of time it takes to do these kind of problems, stuff like that. So, all right, moving on to part number 2. Here comes part number 2. I'm allowed to use my calculator on this one, but not until the first hour of the exam. Now, I left my calculator in my office as I ran down here to get this computer thing working. Can I borrow your calculator? Thank you. Remind me, I'll return it just after we're done here. But just want to show you in case I have to do something special on the test here. All right. So, here we go. Now, in part number 2, you're going to have this type of... this will be actually what the exam is going to look like for you guys. Print your last name first, first name last, student ID number, instructor, what section you're in, but it's pretty much the same idea. You are allowed to use a calculator, but not until we actually give you the official word. But I'm going to let you know right now, most of these problems you can do without a calculator. You're also going to get one of these things, which is your Gradescope OpScan form. You'll get a different one. Part 1, you got one of these guys to fill in the bubbles on part 1. You get a different one for part number 2. And you'll put in your version right up here. Version 1 would be A, version 2 will be B on this particular test. Just to kind of tell you guys what's going on. Yes, sir?
Is each part of the exam 1/3 towards the final grade?
No. The exam weight is this. Part 1, no calculator multiple choice is worth 30%. Part 2 is with calculator multiple choice is worth 30%. And part 3, which is the free response, is worth 40% of the grade. All right. So, this one only has 12 questions. Congratulations. But you're allowed to use a calculator. But even if you don't have your calculator at this point, you can sit there and do most of it, at least to a point. And if you need a calculator for the rest of it, well, then just stop and go on to the next problem, and then don't forget to come back and finish it up. Okay? So here we go. This first problem is, which one of these is the best approximates the length of the curve? Again, when you're doing these particular problems and stuff, length of the curve. What are we talking about? Arc length. So it's another formula you need to memorize. That's the integral from a to b of the square root of 1 plus my derivative squared dx. Does that make sense? Again, a formula put it down in terms of things you've got to have memorized. So here's my function. Y is equal to e to the 2x. What would the derivative be? Chain rule version. Derivative e to the x is e to the x, but derivative e to a function is e to the function times derivative of the exponent. Calculus 1. So derivative e to the 2x is e to the 2x times 2. So this would become the integral from, and my bounds are between 0 and 1, so here's a and here's b, they gave that to me, 0 to 1 of the square root of 1 plus parentheses 2e to the 2x quantity squared dx. And look at these answers right here. Who are we kidding ourselves? This is a calculator problem. Right? So, it's all right. You don't have a calculator right now. You know what I'm going to do? I'm going to move on to the next problem and then come back to the actual answers. Does that make sense? But since it's the review, let's go ahead and put it on the calculator here. All right, so I'll just show you what I'm doing here, just to show you. Math number 9, okay, it's the square root of 1 plus, wrong button there, call that down. Square root of 1 plus parentheses 2e to the 2x, close parentheses, squared, okay? You got the old operating system on this one. Close parentheses, let's see here, yep, comma, x, comma, low bound, 0, comma, upper bound, 1, and you end up getting an argument error, so I made a mistake somewhere on the parentheses, square root of, I would love the new operating system, but I feel bad about this guy having the old operating system, so I should be able to do this thing here. X squared, parentheses, another parenthesis here. There we go. I mean, I can do this thing, and then I'm going to make fun of your calculator in just a second here. But all right, so there it is right there. So I got the answer of 6.494717559. Now you know that I can upgrade this calculator if I actually brought mine with my cord. All right, but here is another calculator. I'm real sorry about the color of it though, but whatever. Math number 9. Second quit here. Math number 9. This is the new operating system. How you can tell they got the actual code on it. Much nicer to play with. From 0 to 1 of the function, the square root of 1 plus parentheses 2e to the 2x, close parentheses squared dx. A little nicer because it looks exactly like what we're trying to type in. So that was something they upgraded on the calculator there, Texas Instrument. But I still get the same answer of 6.494717559. And then they said, of course, quote, we want this thing, what, 2 decimal places or whatever. So this has got to be what, 6.49? Yeah, the answer's A. Does that make sense? Did I lose you guys anywhere? All right. Now look at a problem like number 2 here. And again, you're collecting formulas. Oh yeah, I forgot about that arc-length problem formula. There you go. Make sure you get that thing memorized. You know there's going to be one on the test. All right. Which of the following series converges conditionally but not absolutely? All right. So, which of the following, and if you got a problem like this, and I got a bunch of series that I'm going to have to test, I'm going to start with the first one and then basically march my way all the way down until I find the guy. With my luck, the answer is going to be E, but you know, you get to the last one, but you never know. You may get to stop short a little where. So let's go with this first one. We want to converges conditionally but not absolute. So if we do absolute convergence on this guy, again, you always start with absolute convergence. So absolute convergence, you're going to sit there and take, n goes from 0 to infinity of the absolute value of this negative n cubed, and clean them up. Absolute value kills off the negative. This is the sum as n goes from 0 to infinity of just n cubed. But I happen to notice this, that this series right here, the an part is n cubed, and if I take the limit as n approaches infinity of n cubed, I'm going to get infinity, which tells me it diverges by the divergence test. Does that make sense? So this thing diverges by the divergence test. And even if I go back and put the alternating thing back on there, so it's clearly not absolute convergent. But if I go back and put the alternating part back on there, the sum as n goes from 0 to infinity of negative n cubed. My bn part, without the alternation, again I would use the alternating series test on this guy, would be this n cubed, the part without the alternation. And I end up getting, that's cubed there, sorry about that, n, I had it right to begin with here. There's my n right there. So if I just end up taking the limit as n approaches infinity, you end up noticing that for part number 2, the limit as n approaches infinity of n cubed is still infinity, which even the alternating series test tells me it diverges. The terms have got to get smaller. This thing is not getting smaller. It's just basically, it's divergent all the way. It's not absolute convergent. It's not conditional convergent. The answer on this guy is just plain old divergent. Okay? But now, let's look at the next guy. This guy here is the sum as n goes from 0 to infinity of negative 1 to the n, divided by n squared plus 3. So, again, I'm going to check for absolute convergence by taking the absolute value of this guy. N goes from 0 to infinity of the absolute value of negative 1 to the n over n squared plus 3. When you get rid of the absolute value, it kills off the negative 1 to the n, it turns into this guy. 1 over n squared plus 3. Now, I'm not actually going to do the test, but you should do the mental comparison test. What would you compare this guy to? Compare to the sum of 1 over n squared, which is what kind of series is this guy? It's a p series. And what does this p equal to? 2, which means it does what? Converges. This guy is absolutely convergent. I want one that's not absolute convergent, but conditional convergent. So this guy is out, this guy is out. Let's talk about this dude here. So, going down to my next guy. Here, I'm going to check for absolute convergence by taking the absolute value of my series. The sum as n goes from 0 to infinity, the absolute value of negative 1 to the n over 2n plus 1. Absolute value kills off that negative 1 to the n, and you get the series. The sum as n goes from 1 to infinity of 1 over 2n plus 1. Again, I'm going to do a comparison test, but not completely. It's a multiple choice part of the question here. But what would I compare to for this guy? 1 over the sum of 1 over 2n plus 1. What would you compare it to? 1 over n. And what's this dude's name? Harmonic series. And what does the harmonic series do? It diverges. So this thing is not going to be absolute convergence. So this is a good choice. Now we're going to check for conditional convergence. So for conditional convergence, you put back on your alternating part. This is sum as n goes from 0 to infinity of negative 1 to the n over 2n plus 1. Right? So the bn part is this 1 over 2n plus 1. You're starting with 0 on this one. So number 1, you're going to make sure that things go down. N equals 0, n equals 1, n equals 2. Plug in 0, you get 1, so it's 1 over 1. Plug in 1, you get 1/3. Plug in 2, you get 1/5. Hey, my terms are going down. And number 2, what is the limit as n approaches infinity of 1 over 2n plus 1? 1 over infinity, which is 0. The terms go down, and the limit goes to 0. It converges by the alternating series test. So it's not absolute convergent, but it is conditional convergent. This is my guy. Does that make sense? And just to let you know, if I just looked at the other two guys, this guy is not going to be, I mean, if you take the limit as n approaches infinity of just the natural log of n plus 1, the sequence part of this guy, natural log of infinity is infinity. This thing's going to diverge by the divergence test. Same idea here. What's the limit as n approaches infinity of negative 1 to the n? That's just plus minus 1, minus 1. The thing doesn't converge. It just alternates. 1, negative 1, 1, negative 1. It's never going to converge, so it's not going to be convergent, conditionally or any otherwise. So there you go. But notice how I started at the top and worked my way down. That's a strategy on a problem like this. Take a look at the next guy. Let f of x be equal to x to the fourth. What is, here's another one here, average value. So the average value is equal to the 1 over b minus a times integral from a to b of f of x dx. Another formula you need to put in your quiver of formulas that you need to have memorized. In case you forgot, this was the formula for average value. 1 over b minus a times integral from a to b of f of x dx. So in this problem, my f of x is x to the fourth, my a is negative 2, my b is 2. So this would be 1 over 2 minus negative 2 of the integral from negative 2 to 2 of x to the fourth dx. I would clean them up. 2 minus a negative 2 makes it 4, so this would be 1/4 the integral from negative 2 to 2 of x to the fourth dx. According to the fundamental theorem of calculus, I will integrate and then plug in top minus plug in bottom. So this is 1/4 times integral x to the fourth is x to the fifth over 5, evaluated from negative 2 to 2. With that 1/4 out front, that's that 1 over b minus a. Plug in top minus plug in bottom. This would be 1/4 times 2 to the fifth over 5 minus 1/4 times negative 2 to the fifth over 5. Okay? So here we go. What is 2 to the fifth? 2 times 2 times 2 times 2 is 16 times another 2 makes it 32. This would be 32 over 20 minus negative 2 to the fifth is negative 32 because it's odd. Times that negative makes it back to positive, so that'd be plus 32 over 20. What's 32 plus 32? 64 over 20. You can reduce that by a factor of 2. Actually by a factor of 4. But who are we kidding ourselves? Look at your answers. They're decimals anyway, so I'm going to grab either one because it doesn't matter about the operating system here, but I just cannot handle this green thing, so we have to show you this again. 64 divided by 20 is 3.2. And your answer is D. Does that make sense? Did I lose you guys anywhere on this one? Again, it's real simple as long as you know the formula. Average value. 1 over b minus a times integral from a to b of f of x dx. Here's another classic problem that I put, even on my test number 4 for you guys, it was sad. Here's a geometric series. 3 minus 6 fifths plus 12 25ths minus 24 over 125 plus dot, dot, dot. All right, and we want to figure out what it converges to. Well, on a geometric series, we know that sum is n goes from a 1 to infinity of a r to the n minus 1. It converges to a over 1 minus r, provided the absolute value of r is less than 1, and it diverges provided that the absolute value of r is greater than or equal to 1. On a problem like this, you don't need to write it in this form. Here's the deal. A is always the first number in your sequence. It would be 3. The r is what you multiply the first number by to get to the next number. What do I need to multiply 3 by to get to a negative 6 fifths? I need to multiply by a negative 2 over 5. Agreed? 3 times negative 2 over 5 is a negative 6 fifths. Now you double check it. Now I'm going to multiply that negative 6 fifths by another negative 2 over 5. Negative 6 times negative 2 is a 12, and 5 times 5 is 25. And I can double check him one more time. I'll multiply that term, the 12 over 25, by a negative 2 over 5. And 12 times a negative 2 is negative 24. 25 times 5 is 125. That pretty much tells me as long as it's the same number being multiplied by one term to get to the next term, that is my R value, negative 2 over 5. So now, absolute value of R is absolute value of negative 2 fifths, which is 2 fifths, which is less than 1. This thing is going to converge to the formula a over 1 minus r, which is a, which is 3 over 1 minus r, which is a negative 2 fifths. So this is 3 over 1, minus a minus makes it plus 2 fifths. And so this is 3 over 7 fifths. Invert and multiply. This will be equal to 3 times 5 sevenths. That's equal to 15 sevenths. I just wanted to show you I could do this problem without a calculator, and the answer is B. Does that make sense? Did I lose you guys anywhere? So this is one right off of our test number 4, very recent in your mind. Yes? R value is the number you multiply one term to get to the next term. So the first term was a 3. What do you need to multiply 3 by to get to a negative 6 fifths? You multiply by a negative 2 fifths. What do you need to multiply a negative 6 fifths by to get to the 12 over 25? Multiply a negative 6 by a negative 2, and the 5 times the 5. Once you figure out going from the first term to the second term, then you check it to see if it makes sure it matches up to the rest of the terms. So I really discovered it by going from 3 to the negative 6 fifths that I multiply by a negative 2 fifths. And then I checked it to make sure it's the same number for each one of those guys. And that's my R value. A is the first number in the sequence. That would be the 3. And R is what you multiply by to get from the first term to the second term to the third term. Yeah?
Could you divide to find that as well?
You could. You could, but okay, fine. But you could also take this term and divide by this term to get R. You could do it that way. That will work every time too. But I could just look at them and see that multiply 3 by negative 2 gives me the negative 6, and to get a 5 on the bottom, and then just divide it by 5. And then once I get that R, I just double check it with the next term. Another chapter 8 question. Which of the following tests successfully determines whether the series, the sum as n goes from 1 to infinity, converges or diverges? Before I even look at the answers, let's get the answer. Is it going to converge or diverge? Look at this series here. And what do we notice about it? The sum as n goes from 1 to infinity of n squared over 2n squared plus 5. I happen to notice that the degree of the top is equal to the degree of the bottom. And I happen to notice that if I take the limit as n approaches infinity of the an part, just the sequence part, that's the limit as n approaches infinity of n squared over 2n squared plus 5. Now you can L'Hopital rule this thing twice if you want to, but since the degree of the top is equal to the degree of the bottom, you know the answer is going to be the ratio of the leading coefficients, which is 1/2. And that's not 0. So by the divergence test, we know this thing diverges. Does that make sense? This is a divergent series because the degree of the top is the degree of the bottom. So Is it the test for divergence? Fancy words for the divergence test. Ratio test. Would you ever use a ratio test on this thing? Lord, no. Powers of n and or factorials, and with extra stuff, that's when you use the ratio test. Not on this one. Are you comparing to 1 over n cubed, 1 over n squared, or even just n here? No. Degree of the top is equal to degree of the bottom, so they just very much cancel out. Clearly the answer is A here. Figure out what the answer is first, and then go back and figure out your choices. Does that make sense? This is a divergence test. Here's a classic one right here of basically, and it's a trick. So I want you to pay attention. Now, you can spend a long time on this one, or you can get through the problem in about 30 seconds. Here it is. Find C in the partial fraction decomposition of 8x plus 1 over x times x plus 1 squared is equal to a over x plus b over x plus 1 plus c over x plus 1 squared. So I've got this. ax plus 1 over x times x plus 1 squared is equal to a over x plus b over x plus 1 plus c over x plus 1 squared. Now, in my partial fractions decomposition, I want to figure out what a, b, and c are. The first thing I want to do is take this equation and clear denominators by multiplying by your common denominator. The common denominator is that x times x plus 1 squared. So when I distribute, that'll give you just 8x plus 1 is equal to here, a over x times this x will cancel. You're left with a times x plus 1 squared plus b. Here, one of the x pluses 1's cancel. You're left with x times x plus 1 plus c. Here, the actual x plus 1 squareds cancel, and you're left with x. Now, here's the trick right here. Now, if I did a full decomposition, what x's would you choose? You want to use the annihilator method to be able to do this. It's the quickest. So how many letters you got to solve for? A, B, C. Officially only one of them. But A, B, C, there's 3 letters. So you would pick 3 x numbers. What x numbers would you choose? I would choose, let's see here, -1. What's another one? 0. And I'm afraid there's only 2 annihilators, 0 and -1. So any other number, I would actually pick a 1 or something nice to plug in on this one to find all 3 of them. But this is not an annihilator, so that'll be the last number I used. I'll get an equation with A, B, and C in it. But knowing A and B from these guys, I can be able to figure out what the other guy's going to be. Now, here's the trick. Which one should you try first? First off, what did you want to solve for? C. So I heard I would try 0 first. Look at this equation right here. If you plug in x equals 0, what term does it kill off? The c. Well, you don't want to do that. This is the strategy now to save time. I want to solve for c, so I'm not going to plug in 0. That'll kill off c. But if I plug in -1, that won't kill off the c. Does that make sense? So this is my dude that I'm going to use because that's the only one I need to check. I don't really need to do these other 2 guys because all I got to do is find C. So plug in -1. This will be 8 times -1 plus 1 equals A times -1 plus 1, which is 0 squared, plus B times -1, that's great, but -1 plus 1 is times 0, plus C times -1. Notice it kills this guy off, it kills this off. 8 times -1 is -8 plus 1 is -7 is equal to C times -1, which is -C. This was the guy that didn't kill off the C, so I can solve for the C. Does that make sense? And what does that make C equal to? Divide by -1 on both sides. That gives me C equals 7. Yeah, C is 7. That's strategy and using your head. Don't get me wrong. You could have plugged in 0, then plugged in -1, and figure out what A, B, and C are, and then go figure out the C. You'll get the right answer, but you'll take an extra 5 minutes on doing it. Does that make sense? Here's another classic Taylor polynomial type. So, clean this up here. But look at the question. A very good question on this one. This problem says in the Taylor series expansion of f of x equals x to the 8 minus 100x squared plus 5, about the a equals -1, what is the coefficient of the x plus 1 cubed term? All right, so teachable moment right here, things we're supposed to have memorized, and that is the Taylor series. All right. So in the Taylor series, what is the formula f of x equal to? It is pure memorization. F of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed plus dot dot dot. It's an infinite series. This is what you have memorized. When you hear the word Taylor series, you should write this guy out. Okay? Now, what is the coefficient? Now, here's the deal. A is negative 1, so this is for your benefit. I'm going to plug in A is negative 1. You'll end up getting this. F of x is equal to f of A is negative 1 plus f prime of negative 1 over 1 factorial times x minus negative 1. A minus negative 1 is x plus 1 plus f double prime of negative 1 over 2 factorial times x minus negative 1 makes it x plus 1 squared plus f triple prime of negative 1 over 3 factorial times x minus a negative 1 makes it x plus 1 cubed plus dot dot dot. I just plugged in A is negative 1. Now, understanding that, what's the question? What is the coefficient of x plus 1 cubed? There's my x plus 1 cubed. So what is my coefficient? It's this dude right here. It's the third derivative at negative 1 divided by 3 factorial. That's what I'm after. Does that make sense? That's what I need to calculate. So here we go. F of x was equal to x to the 8th minus 100x squared plus 5. What is f prime of x? What's my derivative? 8x to the 7th minus 200x. Does that make sense? What's my second derivative? Derivative of 8x to the 7th. 7 times 8 is what? 56x to the 6th minus 200. Keep going. What is the third derivative of x? Derivative of 56x to the 6th, again, time for a calculator, is 6 times 56. So 6 times 56 is 336. X to the 5th. Does that make sense? And derivative of minus 200 is 0. What I need to get my coefficient, so my coefficient is going to be the third derivative evaluated at negative 1 divided by, and don't forget this, that's where most people screwed up, 3 factorial. What is f triple prime of negative 1? That's 336 times negative 1 to the 5th. And don't hurt yourselves. What is negative 1 to the 5th odd power? Negative 1 times 336 is negative 336. Does that make sense? So the answer for this problem is a negative 336 divided by, what is 3 factorial? 3 times 2 times 1. What is it? 6. And so my coefficient ends up becoming, grabbing my handy dandy calculator to show you this problem, negative 336 divided by 6 is negative 56. Does that make sense? So the answer is a negative 56, which makes the answer B. Knowing your Taylor series formula. Does that make sense? Question? Yeah.
Yeah, for the previous problem, like, would there also be a problem like where the degree is like more than 1, like where you have to do bx plus b?
No. No. We're not going to do that to you guys on the final exam. We basically use just linear terms. The question was, okay, back to the last problem here, in terms of these factoring. Notice we used linear to a power. This was called the power rule. We're only going to do linear to powers. We're not going to do quadratics to powers or anything like that. We'll wait till you guys get the differential equations before they get you with that one. All right. Number 8 says this. Let a(n) be equal to e to the n divided by n squared. Which of the following is true about the sequence? They have 3 points. I don't know how you guys missed this if you actually passed Calc 1. Question? Yeah. Okay. Well, first off, do you know your Taylor series? Okay. So it's the function of a, first derivative over 1 factorial x minus a, second derivative over 2 factorial times x minus a squared, third derivative over 3 factorial x minus a cubed. They wanted the coefficient of x plus 1 cubed. That cube tells me it's going to be with that third derivative. Cool. All right. So here is a sequence problem here. All right. And basically with sequences, all you've got to do is one thing. Take the limit as n approaches infinity of an. That's all we ever do with sequences, is see if they're going to converge or diverge. You just take the limit as n approaches infinity. So this will be the limit as n approaches infinity of e to the n over n squared. Now to show you your work, the first rule of limits, plug it in, e to the infinity over infinity squared. E to the infinity, reminding yourself, is infinity. However, e to the negative infinity is 0. Just something worth noting right there with your e stuff here. E to the infinity is infinity. It's infinity squared is infinity. It's infinity over infinity. So what does that mean? Call it again. This will be equal to the limit as n approaches infinity of, what's the root of e to the n? E to the n. What's the root of n squared? 2n. Plug in infinity. This would be e to the infinity over 2 times infinity. And e to infinity is infinity over 2 times infinity is infinity. So you got to L'Hopital it again. This will be equal to the limit as n approaches infinity of, derivative of e to the n is e to the n, it's its own derivative. However, what's derivative of 2n? 2. Plug in infinity now. This is e to the infinity divided by 2. E to the infinity is still infinity, but divided by 2 is infinity. You get just a single infinity divergent answer. The answer is, and look at the way they put it. The sequence diverges and we either get infinity or to not to infinity. What does this one do? This one's to infinity. Does that make sense? A little L'Hopital rule twice for calculus 1, but there it is. All right, here's a classic application of the old integral problem here. A 50-pound cable with uniform distributed weight. So trying to make it fancy on you guys. Don't make it fancy, clean it up. Is 50 feet long and hangs from the top of a tall building. How much work is done in pulling the cable to the top of the building? So, here we go. We got ourselves a big old tall building and some dude sitting at the top of it here. And we got this cable, and I'm just going to say the cable runs all the way down. And let's just say it's a 50-foot tall building. It could be more than that, but it doesn't quite touch the ground. Does that make sense? Now, I'm going to put myself a coordinate axis on this guy. So here's my x-axis, here's my y-axis. Here is the 50-foot, and there's my little cable going between the two. We know that we're supposed to calculate the work. Work is equal to the sum of the delta force times the distance that we got to lift. Instead of pump, we're going to be lifting just the little cable. Now, here's the deal. To calculate the delta force is going to be equal to the weight of cable, okay, times a little slice that we're going to make and we're going to analyze. This is a little delta y slice. It's going to be times delta y. That's my delta force. This is coming from that baby Jessica problem that we did on lifting the rope or the cable type thing here. But what is the weight of the cable? They never told you that. They tried to be fancy. Okay, so here we go. Weight of cable. Let's see. We've got a 50-pound cable that is 50 feet long. Let's write that down. 50 pounds, that is 50 feet. So what is the weight of the cable? It is 50 pounds divided by 50 feet. That is 1 pound per foot. Does that make sense? This is that weight of the cable. You want to use that, per distance. Weight per distance is what you're looking for the weight of the cable. This would end up being equal to 1. So your delta force is going to be 1 delta y. Okay? And so that's your delta force. What about the lift? The distance that you're going to lift is this. This was an arbitrary y level that you made this cut. And you're trying to lift it, that arbitrary y, up to 50. It could have been 100. You're just going to change your balance. So as long as it's just hanging, anything above a 50-foot tall building, the cable is just going to weigh there. So I just put my building at 50 just to make it easy. What would that distance be? 50 minus y. Top minus bottom. 50 minus y. Does that make sense? So converting this over, the work is equal to the sum of the delta force, which is the delta force is that 1 delta y, and then the distance I have to lift is that 50 minus y. Converting it to integral calculus, this is the integral of 50 minus y, and the delta y turns into a dy. And all I got to do is worry about my bounds. What are my bounds? Well, where's the cable at? Between 0 and I put the top of the building at 50. Does that make sense? So that would be between 0 and 50. And that's all I got to do. Now, before I finish integrating this problem, oh, well, what do you know? How do you know the building's 50 feet tall? Well, how tall you want your building. As long as the cable's hanging there, anything over 50, you want to be a 100 tall building? Fine. Put 100. Then the distance is going to be 100 minus y, but your bounds are going to be from 50 to 100, where the cable is. You don't have any cable down here if you keep extending the building. You only integrate where the cable is. Yeah?
The cable weight, if it's anything other than y, though, we end up with that as like, if it was like 2 pounds per foot, it would be 2 pounds.
Yes.
Okay.
Yes.
You're
That one right there is 1 times that 50 minus y is just 50 minus
The only
y.
reason that kind of disappears that equation is
Good, because it's 1, yes. If it was like 2 pounds per foot or 27 pounds, that would be a constant up front. And so I can integrate this one by hand. Integral of 50 dy is 50y minus the integral of y is y squared over 2. Evaluated from 0 to 50. Plug in top. 50 times 50 minus 50 squared divided by 2 minus plug in bottom, which is 0. And when I put this on my calculator, 50 times 50 minus 50 squared over 2 is 1,250, and that would be foot-pounds. Does that make sense? So, yeah. Answer C. Considering the following table. There we go again. And here's another formula. So keep throwing those things at you guys. They gave you a table and they want you to use Simpson's rule to be able to evaluate this guy. All right. So here we go. Simpson's rule with 4 subdivisions. This is n equals 4. Okay, to approximate. So to approximate the integral from 0 to 2 of f of x dx, we're going to use Simpson's rule with 4 partitions. Notice n equals 4, which is even, so this is perfectly allowed. Now, what do you need to remember about Simpson's rule? What's the formula? It is delta x divided by 3 times f of a plus 4 times f of x1 plus 2 times f of x2 plus plus 4 times f of xn minus 1 plus f of b. This was your classic Simpson's rule. It's f of a plus a 4, 2, 4, 2, 4, 2 in terms of the internal partitions plus f of b. So, in our problem, what is your delta x? Delta x is b minus a over n. Here, we're going from 0 to 2. That tells me a equals 0 and b equals 2. So this would be 2 minus 0 over n, which is 4. That's equal to a half. So, my partition delta x is a half. So I'm going from 0 to a half to 1, 1 to 1.5, and 1.5 to 2. Okay? So my Simpson's rule for 4 partitions is going to be delta x, which is 1/2, divided by 3 times f of a. A is starting at 0. That'll be f of 0. Plus 4 times f of x1, your first internal point, which will be 0.5. Plus 2 times f of your next internal point, which is 1. Plus 4 times f of your next internal point, which is 1.5. Plus 2 is your endpoint. This is your b. A is 0. B is actually 2. That'll be plus f of 2 because that's your b. Again, I'm showing you this because if this was a free response question, this is the work we want to see. Now you got to plug in the numbers for your function here. So what is a half divided by 3? You can clean that math up. That's 1/6. Times f of 0. F of 0 is 2. Plus 4 times f of 0.5, which is 3. Plus 2 times f of 1, which is -1. Plus 4 times f of 1.5, which is 3. Plus f of 2, which is 6. And at this point, it's time to grab your handy-dandy calculator and add them up. And you end up getting here, this is 30 divided by 6, which means the answer is 5. The answer is E. Does that make sense? Questions? All right, classic Simpson's rule. Remember, midpoint, and so here's the deal. We did a midpoint problem and a Simpson's rule problem. The one we didn't do is trapezoid. Just make sure you know the trapezoid rule problem. Delta x divided by 2 times f of a plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x n minus 1 plus f of b. Number 11. Find the area of the region in the first quadrant of the function y equals x cubed. All right, so they're talking about area here. And y equals 4x. So first thing I'm going to do is draw this guy. X cubed, you got your calculator at this point of the exam, but you don't really need that one. You know it's going to look like this. The classic cube function looks like this. All right, and this in first quadrant, so I am kind of focusing on the first quadrant here. And the other one is y equals 4x. Y equals 4x is a line that looks like this. So there's my y equals 4x line. This is the line of y equals x cubed. So we're talking about this particular little slither right here. That's what we want to find the area of. Now, when do these two guys equal to each other? X cubed is equal to 4x. You can set it equal to 0. X cubed minus 4x equals 0. Factor out an x, you're left with x squared minus 4 equals 0. X times x plus 2 times x minus 2 equals 0. X is equal to 0, x equals negative 2, and x equals 2. But they just wanted the first quadrant. So my bounds are between 0 and 2. I don't care about the negative 2 over here. So 0 to 2 is my bounds. So now, what is the formula for calculating area? Now I got a top and bottom on this guy. So this would be the integral from a to b of f of x top minus g of x bottom dx. Just reminding you of your formula of calculating the area between two curves. Does that make sense? Again, I wouldn't put that on the test. I actually know that one, but I'm trying to help you guys out. So my area is going to be the integral from 0 to 2 of your top function, which is x cubed, minus your bottom function, which is 4x dx. Now you're right, I can integrate this thing by hand if I have to, but you know what? I can also use my calculator at this point, because this is on the calculator active part of your test, just to kind of double check yourself. So this will be math number 9 of the integral from 0 to 2 of your function x cubed minus 4x dx. Question, yeah. Wait a minute. Yeah, I think 4x is on top. And I'm about to show you that right now. What happens when you get that? What happens? What do you get for the answer? I'm trying to put the answer up there. What's the answer? Negative. What does that tell me right there? We got the top and bottom backwards. This was my strategy. So how do I know I screw up a volume problem or an area problem? What do? You get a negative answer. You know with volume and area, you're not supposed to be negative. So the one that's on top is actually the 4x, and the one that's on the bottom is actually the x cubed. Top 4x, bottom x cubed. So it's 4x minus x cubed, and so you can switch that around just to show you what happens here. This would be 4x minus x cubed dx, and notice you end up getting the answer of a positive 4. Remember, when you're playing around with this stuff and you end up getting a negative area or a negative volume of the area between two curves of volume rotation, you got your tops and bottoms backwards, or maybe the point radius backwards on the shell method or something like that. So clearly the answer is 4, and this would be units square of answer there. The answer is 4. Here's another one of those interesting problems where you really hate to see them, but this is the way they're going to phrase the question. Of the series, number 1, the sum as n goes from 1 to infinity of the sine squared of n over n to the 3/2 power. 2, the sum as n goes from 1 to infinity of the natural log of n over n. Number 3, the sum as n goes from 1 to infinity of n over n squared plus 1. And number 4, the sum as n goes from 1 to infinity of n plus 100 over n cubed plus 1. How many of them actually converge? All right. So, let's look at the first one. The sum is n goes from 1 to infinity of the sine squared of n over n to the 3 halves. Well, when you got a trig function sine, I'm going to use the direct comparison test. Now, notice that sine always bounces between -1 and 1. Sine squared bounces between 0 and 1. So this would be less than or equal to the sum as n goes from 1 to infinity of 1 over n to the 3 halves. What kind of series is this guy? P series? What is P equal to? 3 halves, which is bigger than 1. It converges. So since this guy converges, what's this guy going to do? By the direct comparison test, we have convergent. When you're less than convergent, you converge too. So this is a winner. It converges. Does that make sense? I did the direct comparison test on it. That sine squared, you can bound it upper bound by 1, and 1 over the sum of 1 over n to the 3 halves is a convergent P series. This guy here, number 2. The sum is n goes from 1 to infinity of the natural log of n over n. I see that n on the bottom. Natural log of n over n. I'm going to do another direct comparison test, and with that n on the bottom, I'm going to compare to the sum of 1 over n. Now, what's this dude's name? This guy is the harmonic series. And what does the harmonic series do? Diverges. And since this guy is bigger than divergent, what can we conclude from this? From the direct comparison test, that we have divergence. Does that make sense? If you're bigger than something that blows up, you blow up too. I call the direct comparison test to divergence. So this guy we don't want because he diverges. Does that make sense? Because you compared him to the harmonic. What about this guy, number 3? The sum is n goes from 1 to infinity of n over n squared plus 100. I would do a limit comparison test mentally. I'm actually not going to do the limit comparison test unless they actually tell me to. But who would you compare to? N over n squared. The degrees take over because that's your commander. What does that reduce to?
1 over n.
Back to the sum as n goes from 1 to infinity of 1 over n. What kind of series is this guy? Harmonic. And what does the harmonic series do? Diverges. But I don't think I can get my inequality just right, so I would use a limit comparison test, but this is who I compare it to. And so by the limit comparison test, this thing would be divergent because it would compare to a harmonic series. So I don't want this guy. And then number 4. The sum is n goes from 1 to infinity of n plus 100 over n cubed plus 1. Again, your commanders take over. I would do a limit comparison test. And who would you compare to on this guy? What is n over n cubed reduced to? 1 over n squared. What's this guy? This is the P series. P equals 2, which is bigger than 1, which means it's convergent. So by my limit comparison test, these guys are going to do the same thing. And since this guy converges, we have convergence. So this guy. So what is the answer to my problem? None of them, exactly 1, exactly 2, exactly 3, all 4. What's the answer? Exactly 2 of them converge. Does that make sense? Did I lose you guys anywhere? All right. How long did I take for this particular section of test? Question, yeah.
Yeah, so for like the natural log of n or n, would it be better to do the limit comparison rather than the direct?
No, taking the limit as n approaches infinity is actually awful because that's going to go to infinity, and when you take its derivative, it would be 1 over n, it'll make it still go to 0. But it's bigger than 1 over n because natural log of n is bigger than 1, so you can directly compare it to the harmonic series. The other test you could have used was the integral test. You could integrate natural log of n over n and watch that thing integrate to infinity. So now we have part 3. This is the free response part of the test, 40% of your test. And again, part 3, our test tomorrow is going to look like this, and it's very important. Print your last name first, then your first name, print it so we can actually read it, or the computer can. Your ID numbers, you had to bring your ID card, and then your professor's name and your section number. Okay? So, this is the one you want to go out of your way to actually show your work on. So, what about this first problem here? It says this. Even though calculator's allowed, no work means no credit. You actually have to go out of your way to show us the work on this thing. We're grading more than the work. So, here's the first problem. Consider the region in the first quadrant under the graph of y equals cosine of x between 0 is less or equal to x less than or pi, halves. In the case below, sketch the solid form when the region is rotated about a given line. Then set up the definite integral with the volume. Use your calculator, hint, 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 to evaluate and round your answers off to 3 decimal places. So first thing is, I want to take this region, which is y equals the cosine of x. Cosine of 0 is 1, and the cosine, so I'm graphing between 0 and pi halves, the cosine of pi halves is 0, and so we know the graph kind of, it's a cosine wave, it just bounces on forever, but that's pretty much that little section there. You can also use your calculator to graph it if you needed to. Okay? So we're talking about this particular region right here, and we want to rotate it about the line y equals 0. Y equals 0 is the x-axis. Y equals 0, this is my axis. Y equals cosine of x. Now, my function is in terms of x, and I'm rotating around the x-axis, which is the line y equals 0. What method should I use? The function in terms of x rotating around x or parallel to the x-axis. This is a disk washer problem. They even tell you that in the problem, but you should understand, because we don't always tell you the directions on this one. I want you to use disk washer on this one. So volume is equal to pi times integral big functional radius squared minus little functional radius squared dx from a to b. My big radius is going to be from the axis of rotation, which is the x-axis, to the outside edge of my region, top minus bottom. That would be the cosine of x minus 0, which is the cosine of x. My little radius is from the axis of rotation to the inside, but the axis and the inside is the same axis, so that would be 0. So this would be volume is equal to pi times integral from my bounds are between 0 and pi halves of the cosine of x squared minus 0 squared dx. So I get this. Volume is equal to pi times integral from 0 to pi halves of the cosine of x quantity squared. You can also write cosine squared x if you want to, dx. That was your big point total on this problem. Because remember, read the directions. They say, quote, set up the definite integral. This is the definite integral. Yeah, this is what they're looking for to grade. And then they say, use your calculator to integrate. So on this one, math number 9, and I'm using my little nicer, newer operating system here. I'm going to typically leave the pi off of the answer for just a second. So this would be pi times an integral from 0 to pi halves times parentheses cosine of x, close parentheses, because it's cosine squared, but this is how you have to type it in on the calculator. That's why I wanted to show you guys. Dx. And this isn't my calculator, so double check that mode. Make sure you're in radian mode every time you do one of these kind of math problems. And I end up getting pi times 0.785398164. Okay, but they wanted me to round this thing off to 3 decimal places, so now I'm going to stick on that times pi, and this is 2.4674011, and to get it to my 3 decimal places, 1, 2, 3, this is 2.467. This would be volume, which is units cubed. Okay? They just wanted to rotate the volume here. If you wanted to draw what the volume looked like, be my guest. You're rotating it around that line, the x-axis here. So this was your region. It's going to end up looking like a little bullet or something or other. That's what you're trying to write. Does that make sense? Part B asks you to rotate about that same region, but rotate around the line x equals pi. So, again, I'm going to draw the region. You want to draw the picture of these guys. Give them a visual. We also grade off that. You can't do these problems without actually having a visual picture on this stuff. So here is 1, here is pi halves, here is again, this is my region, same region as before. Here is my x-axis, y equals 0. Here is your y-axis. But way over here is the line x equals pi. This is your axis. So let's understand this. My function, which is the cosine of x, is in terms of x. We are rotating around the line x equals pi, which is parallel to the y-axis. Function in terms of x, rotating around y, that's the shell method. Now, they tell you that as well, but you should recognize it in case they don't tell you directions. They just want you to rotate it. You got to use the shell method on this one. This would be 2 pi times integral from a to b of what we call that point radius times f of x top minus g of x bottom of my region dx. So volume would be equal to 2 pi times integral from 0 to pi halves, because that's where my region is located at, 0 to pi halves. Leave a little space for that point radius, we'll talk about him in a second, times the top function, which is the cosine of x, minus the bottom function of my region, which is 0 dx. Let's talk about that point radius for a second. Point radius, you pick an arbitrary point inside your region. Since this is a dx kind of a problem, you want an x arbitrary point, and the distance between that point and the axis. Remember, distance is either top minus bottom or right minus left. We're going vertical on this one, so it is top minus bottom. Excuse me, right minus left. Excuse me. Right minus left. What's on the right? Pi. What's on the left? X. So my point radius is end up going to be equal to that pi minus x. Does that make sense? Right minus left, pi minus x. So again, cleaning it up, you get volume equals 2 pi times integral from 0 to pi halves of pi minus x times the cosine of x dx. Does that make sense? Did I lose you guys anywhere? All right. Now, they said set up the integral. This is the big point total. We give, 2 points or so for the actual calculation. They even tell you to use the calculator on this thing. So I'm going to put 2 pi, and I'm going to put this on my calculator. Math number 9. We are still in radian mode here. From 0 to pi halves of parentheses, your point radius, pi minus x times your function, which is the cosine of x, close parentheses angle, close parentheses on that function, dx. And I end up getting times 2.570796327. And multiplying it times that 2 is 5.141592654 pi. And to get those decimal places they want, just hit it times pi, and you end up getting the answer of 16.15278971. And again, they want 3 decimal places on this guy. So 3 decimal places with that 7 rounded up, this will be 16.153 units cubed of volume. Does that make sense? And what did you find the volume of in this case? Well, if you take this little region right here, rotate it around that axis, x equals pi, you get the reverse image over here. And this is what you found the volume of, just a general shape of the volume, if they ask you to do that. Does that make sense? Questions? All right, each problem is worth 8 points in terms of the free response part, just to let you know what you're looking at and show all details of your work. Question?
Yeah, so like for the previous problem, do we have to for calculating it, do we have to show the steps with pi and all that, or can we just immediately do it?
You can go through that thing. I'm doing this to kind of help you guys out to see how where I got the answer from. You can go straight to that account. Stick the pi on the calculator and straight for the integral answer. But most of the points on that last problem, most of the points were going to be coming from making sure you set up the integral correctly. That's what we're looking at. Yeah?
Does it take off for not putting units cubed?
Yes, on occasion. physics problems and stuff like that. So if you're talking about area, we want units squared. Sometimes they'll give you units on physics. We want volume, we want units cubed. Always pay attention to units, okay? It depends, honestly, on the problem. Sometimes we have in the past and sometimes we haven't, especially if they tell you the units is measured in feet or inches or something like that. They're going to be very adamant about making sure, you know, that inches squared for area, inches cubed for volume, stuff like that. All right, consider the region bounded in the first quadrant by y equals 1 minus x squared on 0 is less than or equal to x, which is less than or equal to 1. Use calculus, all right, there it is. Use calculus to find the x-coordinate of the centroid. All right, so first thing I'm going to do on this problem is draw my picture here. Y is equal to 1 minus x squared. Y-intercept is 1. When you plug in 1 over here, you get 0. So here is first quadrant here. First quadrant. Here's the line y equals 1 minus x squared. Here's 0 and here's 1. Okay? So this is the region that we're trying to find the centroid of. And they want the x-coordinate. So we got to know our formulas. The x-coordinate is equal to, for the centroid, is the moment about the y divided by the mass. And just in case you're looking for it, the y-coordinate, what do you think that one's going to be? That's the moment about the x divided by the mass. But they just want this guy. And again, I'm just trying to help you guys out and to remind you guys of stuff. All right, formula. Mass is equal to density times area. Okay? The density is typically given by this constant rho, unless they change it up on you or something like that, times the area. And how do I define the area under a curve? That's where our calculus comes in at. The area is going to be the integral from 0 to 1 of my function 1 minus x squared dx. Does that make sense? How do I find area? You integrate the function, gives you area from the curve back to the x-axis, which is what we want. So, on this one, what did they tell you to do? Evaluate by hand. Don't get me wrong, I'll still check it on my calculator, but here we go. This will be rho times integral of 1 is x minus integral x squared is x cubed over 3, evaluated from 0 to 1. That'll be rho times plug in top 1 minus 1 cubed over 3 minus rho times plug in 0, pretty much gets 0. And so 1 cubed is 1 divided by 3, 1/3. 1 minus 1/3 is 2/3. This is 2/3 rho. So we've got the mass on this guy being equal to 2/3 rho. And I showed my work and my hand-done integration. Does that make sense? Now the next thing I need for that x-coordinate is the moment about the y. So the moment about the y, pure memorization of formulas. The moment about the y-axis is the tendency to rotate around the y-axis. And if you remember, that was kind of like the disk washer method. This would be rho times integral from a to b of x times f of x top minus g of x bottom dx. This was the moment about the y formula you need to know. So in our problem, this would be rho times integral from 0 to 1 of x times the top function up here is that 1 minus x squared minus the bottom function, which is 0 dx. Okay? So on this one, I'm going to clean it up. So this is rho times integral from 0 to 1 of pretty much x times 1 minus x squared dx. Clean it up. Again, don't skip any steps. Integral from 0 to 1 of x minus x cubed dx. Distribute, so I can integrate by hand. It's usually going to be a simple integral. This will be rho times integral of x is going to be x squared over 2 minus integral x cubed is x to the 4th over 4, evaluated from 0 to 1. Fundamental theorem of calculus, you plug in top minus plug in bottom. Rho times 1 squared over 2 minus 1 to the 4th over 4. Minus rho times plug in bottom 0, 0 squared divided by 2 minus 0 to the 4th over 4 is still 0. So that part goes away. And so this is rho times 1/2 minus 1/4. And what's a half minus a fourth? That's 1/4. 1/4 row. So that tells me, again, I showed my work, and that tells me that the moment about the y-axis is 1/4 row. So to finish it up, to get the x bar, which is your x coordinate of your centroid here, that's equal to the moment about the y-axis divided by the mass. That's going to be 1/4 row divided by 2/3 row. The rows end up canceling out. So your x coordinate ends up becoming 1/4. When you divide by a fraction, invert multiply, that's times 3/2. So your x coordinate ends up being 3/8. Here's my answer. Does that make sense? Did I lose you guys anywhere with this one? But notice the detail of showing my work, because this is free response. And I don't want, if I made a bonehead careless error, trust me, if you make a bonehead careless error, and we can easily identify with good neatness counts showing your work, you're going to get more points than a bunch of chicken scratch on this thing and a wrong answer over here. You started out good. We add on some points until and we try to figure out where we made a mistake at. But we got 2,000 papers to grade on this stuff. I can't spend more than a couple of seconds looking at your paper going, where did you mess it up at, if you messed it up at all. And then where you messed it up at is going to be dependent upon how many points we're going to give you or not give you. Does that make sense? Show your work, and neatness counts. All right? Take a look at the next one, number 3. Take a look at this problem, and then take a look at the one that I put on the your test, and I'm sure Professor Taylor did her same thing on her class as well, on this kind of problem. And it's sad people left it blank. That's embarrassing. You should know this crap. Especially chapter 8. We beat you guys to death with this stuff. You should know how to do this problem. And this was nice because we gave it to you. But even on the test, we gave it to you and we made you manipulate it. Take a look at this problem. Use the Maclaurin series expansion. Merry Christmas. They gave you this one. The cosine of x squared is 1 minus x to the 4th over 2 factorial plus x to the 8th over 4 factorial minus x to the 12th over 6 factorial plus dot, dot, dot. Okay? Valid for all real numbers x. Use the expansion to get the first 3 terms of the power series of the integral of the cosine of x squared dx. So what they want me to do is integrate the cosine of x squared dx. Well, they gave me the power series for cosine. On my test, I gave you cosine of x, and then you had to plug in the x squared, because power series are easy to manipulate. Replace x with x squared. Clean them up, but here it is. All you want to do is integrate this. 1 minus x to the 4th over 2 factorial plus x to the 8th over 4 factorial minus x to the 12th over 6 factorial plus dot, dot, dot. And if you need more terms, catch a pattern. You know, the next one's going to be, what, x to the 16th over 8 factorial. I mean, literally, you got to catch patterns on these things. Now, here it is. So this would be, what's the integral of 1? X. Minus what's the integral of x to the 4th? X to the 5th over 5 times 2 factorial. That's a factorial. I can't read my handwriting here. Plus, what's the integral of x to the 8th? X to the 9th over 9 times 4 factorial. Okay? Right? Minus, what's the integral of x to the 12th? X to the 13th over 13 times 6 factorial. Does that make sense? Plus dot, dot, dot. And don't forget this. Do you see bounds on this thing? Plus c. But that's not considered a term. So I'm going to clean this guy up. This will be c plus x minus x to the 5th over 2 factorial is 2 times 5 is 10 plus x to the 9th over 4 factorial is 24. 4 times 3 times 2. 4 times 3 times 2, which is 24 times 1, times 9. And that's 216. Okay. So that's 216 minus x to the 13th over 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. I am sticking this on my calculator just to let you guys know that's what I'm doing. And then that's 6 factorial times 13, because I want some nice numbers on this thing. That's 9,360 plus dot, dot, dot. But then the last thing I'm going to do is make sure I answer the question. And make sure you answer the question. What did they want me to write out? The first 3 terms. The plus c doesn't count. So the answer is going to be c plus x minus x to the 5th over 10 plus x to the 9th over 216. There is my answer. You'll see why I want to do one more term. It's always good to catch a pattern on this thing here. All right, so there's my answer. Does that make sense? First 3 non-zero terms here, and don't count the c. Yeah.
No, wait, why wouldn't it be x minus x to the 5th over 10 plus x to the 9th over 216? And you said why would it be plus c?
It is. I just put him in front.
Oh, okay.
Doesn't matter if you put him in front or put him back. You need a plus c somewhere because there's got no bounds on this interval. But here's the first 3 terms. Now, part B. This is this is amazing on my test. I had people actually get this part right, and then they couldn't pull this crap off. Look at part B. Use part A to approximate the integral, and now we got bounds. Integral between 0 and 0.9 of the cosine of x squared dx. Round your answer off to 4 decimal places. All right, they want to use the first, and with the bounds, you don't need the plus c part, so you've already integrated. This will be x minus x to the 5th over 10 plus x to the 9th over 216. Okay? And so now, you put your bounds on there between 0 and 0.9, and according to the fundamental theorem of calculus, you plug in top minus plug in bottom. 0.9 minus 0.9 to the 5th over 10 plus 0.9 to the 0.9, John. Yeah, 0.9 to the 9th over 216. Plug in top. Minus, when I plug in 0 on this thing, it's 0. So here it is, calculator time. And I'll just grab this one because it's right here. Turn it on. This will be 0.9 minus parentheses 0.9, close parentheses to the 5th, over error divided by 10, plus 0.9 to the 9th divided by 216. And what do I get for this answer? 0.8427446134. Does that make sense? Did I lose you guys anywhere? And now, they want me to round this off to how many decimal places? 4. 1, 2, 3, 4. That would be 0.8427. And this is what I would put in the answer box. Now, we're doing the grade scope thing. There'll be answer boxes we want you to put these answers into. Does that make sense? And I'm going to double check something or other because I have a brain. And I got a calculator that belongs to somebody else. So, here it is. Math number 9. Integral from, what was it, 0 to 0.9 of, what was my function here? It was the cosine of x squared dx. This is what we were trying to approximate. You are mimicking what the programming is on the calculator. But we only did, 3 terms? So we stopped short. So the answer I'm about to show you should be very close to this one, but slightly off. There it is. And notice the first 4 decimal places are exactly the same thing. It's right there at the 5th decimal place that it's actually off a little bit. But if you use more terms, you'll get the exact answer on the calculator because that's the programming on the calculator. So I'm feeling real good about my answer. But I'm feeling better because here's the deal. No work is no credit. We always have these interesting individuals. I won't call them any names. But they'll give them this problem right here. Tell them to use the series from this guy. They'll stick this on the calculator and they'll get this. They'll get the right answer, but there's no work involved. We usually take off extra points for that. So don't show your work. So there'll be no points whatsoever for just calculator answer. All right, but now notice this guy here. And this is why I always do a little extra until then I give you my answer. Use the alternating series estimation theorem to give an upper bound for the error you got in part A. So if you notice this thing here, the integral of 0 to 0.9 of the cosine of x squared dx is equal to that 0.9 minus 0.9 to the 5th over 10 plus 0.9 to the 9th over 216, plus dot, dot, dot. Now, it alternates, plus, minus, plus. So this is the alternating series estimation theorem. We know that the remainder for, in this case, 3 terms, which is equal to the true sum minus the partial sum of 3 terms, is less than or equal to b n, which is 3 plus 1. You remember this alternating series estimation theorem. Alternating series estimation theorem says this. When you got an alternating series and you cut it off, the next term up will be your error. Does that make sense? So, I got to go figure out who is B4. What's my B4 term? And it's absolute value, so we don't care about the alternating part. So I came over here. This is why I wrote out 4 terms. 1, 2, 3. There's the 4th term right there. It's absolute value. So the 4th term is this actual x to the 13th over 9,360, and x is equal to 0.9. Does that make sense? You see where this 4th term came from, because I had to go all the way back up here to actually get my 4th term. And now plugging in 9, I get my error on 3 terms to be less than or equal to 0.9 to the 13th divided by 9,360. Yeah. And so, again, putting it on my handy dandy calculator here, when I plug this in, I end up getting 0.000271566862862 on my calculator. It's actually 2.7 e negative 5, by the way. And so there is going to be my error, which you notice I got these 4 decimal places, so I'm accurate within 4 decimal places according to this thing. Does that make sense? And if you don't believe me, fine. Here it is. 0.9 raised to the 13th power divided by, what was that number? 9,360. And notice that e negative 5, so I just moved my decimal place 5 places to the left, 0.0000. Question, yeah?
So for a problem that doesn't say round to any decimal places, so you have to write it out?
Write it out, absolutely. We're engineers, we're science majors, we're STEM majors. Rounding is for lightweights that causes error. We don't want error. Give them all the decimal places unless they specify otherwise. Yeah?
We leave it as the e, the negative 5.
You can do that, but it really shows if you move the decimal place over how accurate the thing really is by seeing all those zeros. What a surprise on the next problem. Big point total here. It says this. No, this is easy. All right, so a right cylinder tank sits on its base. The base has a radius of 3 meters and the tank is 5 meters tall. The tank is filled with sludge. It gets even better. The density of the sludge is not constant. Rather, the density is given by rho of x equals x plus 32 squared kilometers per meter cubed. Where x is the distance from the top of the tank, and that right there is very important. Where x is the distance from the top of the tank, and set up and use your calculator to evaluate the definite integral that gives you the work done in pumping the sludge out of the tank. Gravitational constant is the greatest because it's a metric system, 9.8 meters per second squared. So first thing I want to do to this problem is I want to write down what we got. We have a tank. On this particular tank, we know that we have a radius of 3 meters. We have a height of 5 meters. We were given that the density, which is your rho, is equal to x plus 32 squared, and x is equal to the distance from top of tank. Their words. Okay? This is x. Pay attention to that. Okay? Now, here we go. The next thing that I want to do on this problem, because we're talking about pumping this stuff out, I got to put a coordinate axis on this guy. So I'm going to put my coordinate axis on this one, and I always put it at the bottom unless the cross section is circular. So here it is. Radius is 3, so this would be 3 to negative 3. There's my cross section. The height is 5, so that's up here. Okay. So here comes my tank. And we want to pump all the sludge to the top of the tank. So my target is the 5. It's at the top of the tank. Okay? We know that work is equal to the sum of the delta force times that distance that we have to pump. Delta force is going to be equal to, changing my word here, this would be, not instead of water weight, it is sludge weight. Okay, times your delta volume. And sludge weight, by the way, something new on this one, sludge weight is going to be equal to density times 9.8 meters per second squared. Okay? So, here we go. This would be that x plus 32 squared times 9.8. That's my sludge weight. That cleans up to be 9.8 times x plus 32 squared. Now, here we go. Keep going here. Now, what is my delta force? Well, I need my delta volume. So to get delta volume, I'm going to come up here somewhere in the middle of my tank and make a little cross-sectional slice. And when I pull that sucker out, you'll notice that it's disc-shaped. So for your delta volume, it's always going to be box shape or disc shape. Because my tank is a cylinder, it's circular, disc shape. The height is delta y, the radius is 3, delta volume being a cylinder is pi r squared h, something you should know. So delta volume would be pi times 3 squared times delta y. So your delta volume is equal to 9 pi delta y. Okay? That makes my delta force be equal to the sludge weight, which is your 9.8 times x plus 32 squared times 9 pi delta y. This is that sludge weight times your delta volume. Okay? Now it gets better, so here we go. All right, work is equal to the sum of that delta force. Delta force in here, delta force, which is at 9.8 times x plus 32 squared times 9 pi delta y times the distance that we have to lift. The distance we have to lift is the distance to the top of the tank. Remember, this was made at an arbitrary y section. Where's the top of the tank? Where's my target? 5. So the distance that we have to pump is equal to top minus bottom, 5 minus y. Does that make sense? So the distance we have to pump, the distance we have to lift that sludge to is 5 minus y. Now I'm going to convert this into integral calculus, and you'll see there's a problem here. This is going to be the trick. So I'm going to pull out my constants here. So 9.8 times that 9 is 88.2. This will be 88.2, just multiplying my constants together, pi. Summation turns into integrals of x plus 32 squared times 5 minus y. Delta y turns into dy. So I've almost got my integral here, except for one problem. What's my problem?
You have two variables.
I got that x in here. What did x represent? X represents the distance to the top of the tank. And so over here, what is x going to be equal to? This slice was made at a y level. This is the x, which is your distance to the top of the tank. What was that distance equal to? So what is x actually equal to? What was the distance we have to pump? What is x equal to? It's actually 5 minus y. And that's the distance to the top of the tank, from wherever the sludge is located at. You're at this distance. You've got sludge at the top, which is a little lighter. Sludge at the bottom is thicker. you know, so the distance, so that density is to the top of the tank, 5 minus y. So I got to replace x with 5 minus y. So this turns into 88.2 pi times integral of 5 minus y, plugging that in for x, plus 32 times 5 minus y dy. So work is equal to 88.2 pi times integral of, what is 5 plus 32? 37 minus y times 5 minus y dy. And I forgot my square. Sorry about that. Squared there. And my question is, what's my bounds? It is from where? You got it. From 0 to 5. This right here is my actual work. Does that make sense? Set up the integral. And then it's nasty, so we will use our calculator to integrate this thing. And did they say how many decimal places? No. So I'm going to leave the pi off on the answers. Just give them all the decimals here. This will be 88.2, math number 9, integral from 0 to 5 of, parentheses, 37 minus x, close parentheses, squared, times 5 minus x, close parentheses, dx. So I end up getting the answer to be 137,941.25 pi. And what would my units be? And if you don't put the units, you lose a point or two. This is work. And this is all in the metric system. So what is it? Joules. And if they want you to write it out so many decimal places, you multiply it times that pi, and you end up getting the answer of 432, okay, 8930.108 joules. There is my actual answer for the amount of work done. 4,328,930.108 joules. Question? Yeah.
What would the cross section be for this problem?
It's a rectangle. It's because it's a tank on the side.
And it's disc shaped, right?
And when you make a slice vertically, it's disc. Yeah. And then problem number 5. Well, we're back to doing the midpoint formula again. With the error-bound formulas. But nice enough they gave you the error-bound formula on this one. All right, so it says this. Consider the definite integral from 0 to 1 of 1 over x plus 1 dx. Use the midpoint with n equals 2 subintervals of equal length to approximate the definite integral above. Round your answer off to 2 decimal places. Be sure to show your work. So over here, we're trying to integrate the integral from 0 to 1 of 1 over x plus 1 dx. So my function here that we're trying to integrate is that actual 1 over x plus 1. Okay? Where most people screwed this up on this problem right from the get-go. They integrated, got the natural log of x plus 1. That's what you're trying to approximate, dude. Yeah, you can actually integrate this guy, but we don't want to integrate him. We want to use the midpoint rule to approximate the integral. So my function that we're trying to integrate, which is your f of x, is 1 over x plus 1. Okay? Now, here, your a is equal to 0, your b is equal to 1, and they tell you that n is equal to 2 subintervals. So from that, I'm going to go after my delta x, b minus a over n. That's 1 minus 0 over 2. That's 1/2. So always draw out at least your axis here. We're starting at 0. We go over 1/2. Another 1/2, we go over to 1. Okay? 0 to 1, 2 partitions. Here they are. Okay? But we're supposed to use the midpoint. So what is the midpoint between 0 and 1/2? 1/4, a quarter. What's between 1/2 and 1? What's the midpoint? 3/4. So these are the midpoints. And to remind you, your midpoint rule for two partitions is that sum of f of xi bar, the midpoints, times delta x. You've got to show me this work. This would be f of your first midpoint, which is 1/4, plus f of your next midpoint, which is 3/4. But there's only two partitions, so there's two f numbers, times your delta x. You have to show me that work. That's what we're looking for. Now, this is equal to f of 1/4. This was my function. You got to plug it in there. This would be 1 over 1/4 plus 1 plus 1 over 3/4 plus 1 times your delta x. What is your delta x equal to? 1/2. Now, if you want to, you can actually clean this stuff up. You didn't have to because at some point you use a calculator, but you got to show us you plugging numbers in. Don't leave it here and then go for the answer because we know what we gave you guys in terms of your calculator project program stuff here. All right? So, what's 1 plus 1/4 is 5/4. Invert, that'll be 4/5. Plus 1 plus 3/4, that's 7/4. Invert, that's 4/7. Times 1/2. And so when I put it on my calculator, double check me on this, but I got 0.6857142857. But they did say 2 decimal places. So M2 is going to be equal to how much? 0.69. Does that make sense? Did I lose you guys anywhere? Now, it's not my calculator, so I got to double check it. Do we have a program on this thing? No, you didn't put the program on yours. Shame. Okay. All right, program. Turn it on. Program. We got lots of programs on this one. Do you happen to have mine? Yes, you do. All right, so here we go. Y equals, let's plug in my function. 1 plus parentheses, 1 divided by parentheses, x plus 1. Program, number 8 on this one. All right, what was A? 0. What was B? 1. What was the number of partitions? 2. And I hit enter, and I just screwed it up, so let's do it again. I enter twice. So 0, 1, 2. There it is. We want midpoint, and double check that number out right there. I'm feeling real good about my answer. I showed my work, so yes, use your calculator to double check this stuff. You definitely want that program going on. Now, part B, to finish this thing up, is we want to talk about the error on this particular problem. All right. So, on this particular problem, the error bound form for the midpoint is this. Error bound is k times b minus a to the fifth over, it's going to be b minus a to the third over 24n squared. To determine how large of an n we need to approximate the midpoint to be within 0.00001 of the answer. Well, the first thing you got to do is you got to find k. K is the maximum value of the second derivative. My function is, again, 1 over x plus 1, which is x plus 1 to the negative 1. So my first derivative is negative 1, x plus 1 to the negative 2. Derivative outside, inside stays the same time, derivative inside, which is 1. This is just negative 1 times x plus 1 to the negative 2. My second derivative is going to be negative 2 times negative 1, which is 2 times x plus 1, subtract 1 to the negative 3 times derivative inside, which is 1, which when you clean that up, that's actually 2 over x plus 1 cubed. There is my second derivative. My bounds are between 0 and 1. So I'm going to graph this guy between 0 and 1. When I plug in 0, I end up getting 2. When I plug in 1, 1 plus 1 is 2, cubed is 8, 2 eighths is 1/4. Here's about a quarter right here, that's that point. And it's going to look like this. You can also put it on your calculator, but there it is. Where is your k value? It's the maximum value. Max value of that second derivative over that interval. Okay? And where's that going to be at? K equals what in this problem? 2. It's right here. There's your max value right there. K equals 2. Now that I've got that, that's half the points on this thing right here. Now, here we go. EM is less than or equal to k times b minus a cubed over 24n squared. Okay? And so this k is 2 times your a is 0, your b is 1. That'll be 1 minus 0 cubed over 24n squared. And that's got to be less or equal to that point 0, 0, 4 zeros, 0, 0, 1. Does that make sense? K is 2, B is 1, A is 0. We're solving for n. How many n's do we need to have? And don't forget we got a round on this thing. You have a whole number integer here. So 1 minus 0 is 1, cubed is 1 times 2 is 2. 2 over 24n squared is less or equal to 0.00001. Okay? I would multiply by 24n squared. I know I could reduce my fractions, don't care. So you get 2 is less or equal to, and again putting on my calculator to make sure I don't screw this up, 0.0001 times 24 is 3 zeros, 0.00024 n squared. Solving for n, I'm going to divide by 0.00024. Divide by 0.00024. So you end up getting n squared has got to be greater than or equal to 2 divided by 0.00024 is 8,333.33333. Now what do you got to do to solve for n? Square root of both sides. N's got to be greater than or equal to, and plugging in this number, square root on my calculator here, I end up getting 91.287,09292. But what do we do with n? I don't care what the decimal is. You can't have a 0.82 of a partition. So what do? You round up. Rounding up tells me n has got to be how much? 92. And that's what goes in the blank where there's the what's involved. Does that make sense? Now this clock's about an hour off here, but how long did I take to do this whole test with explanation? About an hour, about how much? 2 hours and some change. There he goes, 2 hours and 26 minutes. And don't forget the first 5 minutes was me just talking about all the things you got to do. All right? So, the last thing I want to do before I let you guys go is this. Because it's embarrassing because I know this is going to be on your exam. So it's sad if you guys can't do this. So I grabbed the copy of it for my students, but if you're in Professor Taylor's class, you can watch along. Yeah. Well, officially you're supposed to memorize it, but I think they're going to give it to you on the test. Okay, they gave it to you last time. The last 3 tests they gave it to you, so they're probably going to give it to you on this test. All right. Here's the deal. I can't make them much easier than this, so here it is. But people seem to want to screw this problem up. So this is one that was on my test. This is version A, by the way. Here it is. Recall that, and it was sad that I gave you guys this, but I'm trying to mimic what they're going to do on the final exam. Sometimes they give you those 5 memorized power series, and sometimes they don't. This time I did. You're supposed to find the power series for the arc tangent of x squared. But here's the deal. I made you do 4 non-zero terms. How many terms did I write out? 3. I messed you guys up. I didn't give you all you needed. You need to catch a pattern. What would the next term be? Minus x to the 7 over 7. And how do I do this? We love power series because they're easy to manipulate. All I'm going to do is replace x with x squared. So this is x squared minus x squared cubed over 3 plus x squared to the 5th over 5 minus x squared to the 7th over 7 plus dot dot dot. Clean it up. This is x squared minus power to a power you multiply. You'd be amazed how many people screwed that up. X to the 6 over 3 plus x to the 10th over 5 minus x to the 14th over 7. And that is my answer. The arc tangent of x squared is power series x squared minus x to the 6 over 3 plus x to the 10th over 5 minus x to the 14th over 7 plus dot dot dot. Now, I have people who got this part right, and they didn't even do the second part. How embarrassing. You know something, write something down. We want to integrate 0 to 0.5 of the arc tangent of x squared using the answer up here. This would be dx, don't forget that. So this would be the integral from 0 to 0.5 of x squared minus x to the 6th over 3 plus x to the 10th over 5 minus x to the 14th over 7 plus dot 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 dx. Integrate it. Integral of x squared is x cubed over 3 minus integral x to the 6th is x to the 7th over 7 times 3 plus integral x to the 10th is x to the 11 over 11 times 5 plus integral x to the 14th is x to the 15th over 15 times 7 plus dot dot dot, evaluated from 0 to 0.5. And now all I got to do is plug in top minus plug in bottom. This would be 0.5 cubed over 3 minus 0.5 to the 7th over 21 plus 0.5 to the 11th over 55 plus, let's see here, this is a minus, sorry about that, minus 0.5 to the 15th over 15 times 7, 105. Minus, plug in bottom is 0. So what do I end up getting on this answer? Well, let's just take a look. I'll show you, I put it on the calculator. 0.5 cubed over 3 minus 0.5 to the 7th divided by 21 plus 0.5 to the 11th over error divided by 55 minus 0.5 to the 15th divided by 105. And I end up getting 0.0413032331. Sorry, right off the calculator. Now, use your brain and your calculator. We are estimating the integral from 0 to 0.5 of the arctangent, tangent inverse of x squared dx. And I want to check it out to make sure it's within this accuracy here. So that's why I gave you the accuracy. And I should get pretty darn close to the same number. At some point, it's going to be off because we did it. But you notice where it's off is within that many decimal places. So I know I got it right. Was that hard? No. Hey, power series are easy to manipulate. Look at this one. I'll show you where most people messed up on this one here. Recall this guy here. I gave you the power series for 1 over 1 plus 1 over x plus 1 plus x. We want to find a power series for this guy. Here's people couldn't figure this out. What's the relationship of the natural log of 1 plus x and 1 over 1 plus x? Well, to get the natural log of 1 plus x, you actually have to integrate 1 over 1 plus x. If you don't know that, well, back to Calc 1 we go, and we'll start this game all over again. All right, so I gave you the power series for this guy, and they said 3 non-zero terms. So this would be the integral of 1 minus x plus x squared minus x cubed. I always do more than I need, just in case, and then write down what I want. Integral of 1 is actually x. The integral of x minus x is minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot dot dot. Okay? We want the first 3 non-zero terms. Now officially you got a plus c on this guy because you integrate it. We don't count that term here. And I can tell you right now the c is actually going to be 0 because the natural log of 1 plus x is this c plus x minus x squared over 2 plus x cubed over 3 stuff here. And when you plug in 0, the natural log of 1 is equal to c plus a bunch of 0 terms here. And the natural log of 1 is 0, so c equals 0. So you didn't have to write the 0. But if you did write the c, that's fine. It was 0. But the answer was this. X plus, excuse me here. It is x, there it is right there. X minus x squared over 2 plus x cubed over 3. That's a minus right there. This is what we were looking for. 3 non-zero terms. Now, here's where most people screwed it up. What is the natural log of 1.1? Well, remember, you're using the function of the natural log of 1 plus x. What does x have to be to get 1.1? 0.1. A lot of people chunked in 1.1. That was sad. So this would be 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3. And you end up getting your answer on that one here.
Yeah, with that one, I was like wondering like why it was like way off when I was plugging in.
Right, and that's because you were plugging in the wrong number. Squared divided by 2 plus 0.1 cubed divided by 3, and I end up getting 0.095333333. Now this one right here, just I'm going to finish this up quickly, I'm not going to actually do them for you, is this. This is an alternating series. It's got a factorial in it. What test would you use to figure out if this thing converges or diverges? Ratio test. And you'll end up getting, with the factorial on the bottom, you'll end up getting L equals 0, which is less than 1, which means this series is going to be absolutely convergent. You can look at it because it's got a factorial in it. Factorial on the bottom, series always converges. Factorial on top, series almost always diverges, except at the 0 point, whatever. So that's really easy to see, but a ratio test was the answer, and L would be 0. And now you find the first 4 terms. So starting at 1, 2, 3, 4, add them up, and then the error is going to be that 5th term as you write this thing out. That was the test, and I can't make them much easier than that. And this is the type of stuff that's going to be on your final exam. So study hard. And for my class, I'll see you guys tomorrow about 5 o'clock over in Epic. So see you guys then.